So good morning everyone, Assalamu alaikum. We'll start today's event. Welcome to this 161st edition of the Zak World of Façades conference series. My name is Ahmed. I'm part of the organizing team here at Zak. I'll quickly introduce the event to you before we get into the proceedings. So we've been organizing the Zak World of Façades conference series since 2012. This is edition 161, finished the event in 42 countries around the globe. This is our fourth event here in Jeddah, and these are the events which we've planned to do in 2025. So a lot of new countries. We're going to Uzbekistan, we're going to Georgia. These are places where facade events have not happened, so we're experimenting with newer markets. And of course, the way facades are designed, engineered, installed in all these different regions are different. In some regions, it's about carbon. In some regions, it's about cost. Some regions, it's about complex geometry, high-rise facades, and looking at different new materials. So no two events are the same. They're completely different. These events are courtesy our event partners. I'd like to take a moment by thanking all of them, starting with Ephesus. So Ephesus is our associate partner. They have membranes and vapor barriers which help you seal your facade and help in a better facade weatherproofing. Fujairah Rockwool factory, they've got passive fire protection for curtain walls and ventilated facades. Future Architectural Group, they have architectural glass and fire-rated glazing solutions. Curare is the mother company of the laminated glass interlayers, Throsifol and Sentry glass. They help in keeping the glass strong and safe. Leaders Fort are the distributors of terracotta of molding, and they also have some brick cladding solutions. Brick is not used a lot in the Middle East, but I believe it's a good sustainable alternative. It's part of the molding group. Mitrex with their partners Empereal. So building integrated photovoltaics have taken a huge leap from when the older days you had the BIPV panels, but now you've got them in decorative solutions. You also have in transparent solutions. Empereal and Mitrex are leading the way here in this region with their BIPV solutions. North Glass from China, one of the leaders in jumbo glass solutions. So they have glass which can go 20 meters plus. They are specialists in complex curved glass and jumbo glass solutions. SHBO Group from China, again, they're into complex steel structures. They've got steel systems and steel profiles for complex steel projects in the envelope. Silkar Stone from Turkey, so they've got stone laminated cladding product, which is again an alternative to your conventional stone. It's much more lighter because it's a stone laminated panel. All our exhibitors have booths outside, so please do meet them and network with them in the breaks. And just a quick run through of our next few events. So we have New York in the next week, actually. London on the 6th of November. Casablanca on the 28th of November, and of course Riyadh end of the year. And our events in the Middle East next year is Cairo, Dubai, Jeddah, Riyadh, and Tashkent. These are our events for 2025. This year's Jeddah edition, we've got some new topics. We've got sorry, my throat's not all right. We've got facade acoustics, we've got terracotta, we've got weatherproofing. These are topics which we have not discussed at our previous editions. So I hope you will enjoy today's speaker's storytelling. And until we meet next time, I hope you enjoy today's day. We've recorded today's event, so those who have given us permission to share with you the recording, will give you a YouTube link which you can then use to rewatch, to watch the event again. And I won't take too much of time. I'd like to call upon today's event host and convener, Mr. Albaraa from HAK Architects. He's going to be hosting today's event and taking you through until the end of the day. Thank you.
السلام عليكم. أهلا وسهلا بكم في Zak World of Façades. I am Albaraa Zamzam from HAK, an architect. I am honored to be your host today. Actually, as an architect, I feel how it is important to stay up to date with the latest trends and new technologies. And through this conference, we will have the opportunity to meet with the experts in field and discuss new technologies and networking, and of course, in the breaks, networking with industry professionals. Today we have 13 presentations divided into 3 sessions. Each session's about an hour and a half. And we'll also have 2 breaks for tea and coffee and of course networking and lunch and prayers. We hope you enjoy. Without further delay, I would like to introduce our first speaker, Dr. Mohamed Mahgoub, Construction Manager at Ritz Global, with PhD in Construction Management and over 19 years of experience. He will talk about transforming building performance with passive house principles in extreme arid environments. Please give him a warm applause.
Good morning. It's my pleasure to be with you here today, and I would like to thank Ahmed and the organizers for this invitation. It's not my first time to be with Zak, but really I will be happy with you this time. A little bit about myself. I am Dr. Mohamed Mahgoub. I am working in the Ritz Global as a construction project management, but actually today my topic is not related to my work with Ritz. My topic today is related to the passive house and how to design zero energy building and ultra low energy building based on the passive house standard. This topic didn't start today. This topic started long time ago, since 2015, when I started to look into a topic to my PhD. Actually, I'm interested in sustainability, and I would like to have the knowledge of sustainability. So I started to go to Masdar City in Abu Dhabi, where there's an eco villa there. And then I met Dr. Alex Amato, head of sustainability in Qatar Green Building Council. And after I met him, I found that they built a passive house in Qatar, which is called Baitana Project. And I decided to transfer this knowledge to the KSE and UAE as well. So our topic today is transforming building performance with passive house principles in hot arid climates. Today we'll go through background and the human impact on climate change, and why we are targeting building, sustainability in architectures, passive house, case studies, passive house with primary energy, and the 2 models which I developed already. I will introduce both of them for you, and how to implement passive house on wider range in the GCC. So before we start, I'd like to ask you, anyone here believe in climate change? You believe in climate change? Okay, anybody doesn't believe in climate change? So we all here agree for the principle. Okay, so let's start with this background. Okay, as you can see, the atmosphere is acting as a bulb around our plant. Okay, the sun radiation travels from the sun towards the earth. Half of this is being reflected and half is being absorbed by the planet. And this is very important for us to support our life. The greenhouse gas, which consists of CO2, mainly of CO2, it works to absorb this radiation and keep our plants warm, which we call it natural greenhouse gases. But actually there is another source of greenhouse gases, which is the human. Starting from the industrial revolution, there was a rapid increase in greenhouse gases emissions due to fossil fuel burning, which is required for the energy consumption which is required for the energy consumption for our energy needs. So the human resources are the major contributors from human activities, includes burning fossil fuels such as coal, oil, and natural gas, burned for our energy and transportation, produce large amount of CO2. Some greenhouse gases like CO2, methane, and started to be more in late 17th century, which we suffer from now for climate change. So since the human industrial revolution, human activities has significantly increased the concentration of these gases in the atmosphere. The burning of fossil fuel for electricity, heat, and transportation is the largest single source of global greenhouse gases. The increase of greenhouse gases have enhanced the natural greenhouse gas, leading to global warming and climate change as well. So the greenhouse gases effect is essential for our life on Earth, but human activities have affected this and has caused the climate change. Building is a very big sector and contributor to the greenhouse gases. So according to the International Energy Agency, building and construction account for nearly 40% of greenhouse gases in the region, all over the world. So there's 4 main factors, like such operation energy, okay, which such as energy during building operation life, including HVAC, lighting, and appliances, contribute to about 28% of global CO2 emissions. Embodied energy, which is required for manufacture, transportation, construction of building materials, which is responsible for 11% of global CO2 emissions. Also, buildings they have effect by increasing the temperature of 1 to 3 degrees, which is called the heat island effect. We also need water. Building in hot arid climates often require significant water for cooling system to keep the building cool. So what consumes energy in building? Mainly heating and cooling, lighting, and other appliances. So we have heating, ventilation, air conditioning systems. These are among the largest consumer of energy in building. The efficiency of this system heavily influences overall energy consumption. So for this, we should have codes and the sustainability rating system, which could improve the energy consumption in building. We have two approaches to achieve this. We have the holistic approach as sustainability and the green building rating system, like LEED, BREEAM, GSAS, QSAS, and Mustadam. We have also energy performance and certification schemes. And we have also the passive house, which bridges the gap between the holistic and energy performance schemes. So for green building system, it takes a comprehensive approach to sustainability. It looks into many factors, such as LEED, okay, excuse me, and BREEAM. They use point-based scoring mechanism to rate building on scale, often resulting in maybe silver, gold, and platinum LEED, pass, good, and very good, excellent in BREEAM. So the LEED developed in US and it's also being used here in the Middle East. It's focused on sustainability site development, water saving, energy efficiency, material selection, and environmental air quality. BREEAM also the same concept, but it looks into the whole and wider environmental aspects. For energy certification schemes, there are performance-based schemes. Like there's a standard, we need to follow this standard, and this standard, there's criteria, we must meet this criteria. We must this criteria make assessment, analysis, rating, and at the end we have certification. And now we have the passive house. The passive house is a unique standard for ultra-low energy building. It focuses on making building use very little energy or for heating and cooling, which almost 90% less for heating and cooling. It also provides thermal comfort, ensure indoor temperature, and also it should contain air tightness layer. And it's also use durable material. During the several recent years, passive house has rapidly increased in Empereal, with over 44,000 units certified according to the passive house standard from the Passive House Institute. And it's almost 4 million square meter traded floor areas. But how the passive house could be used to mitigate the climate change? The passive house, as we said earlier, it consumes 90% energy less than built as usual building. It mitigates the heat island effect. It has low carbon footprint because they use 90% less, and they use durable material. So the benefits of passive house is you do use 90% less material. They use durable material, as I said, and it offers many benefits to use this low energy material. There's 3 passive houses which I saw in the Middle East. One, as I said before, is the Baitena project in Qatar. It uses around 50% energy less than consumed by other traditional building, and the Eco Villa in Abu Dhabi use 40% less, and the net zero energy building, this in Oman, use 70% less. The Baituna project in Qatar, they are, as I said before, it's two prototypes. One is Baituna project designed and built according to the passive house standard, and the other one is used and is built according to meet LEED requirement. So there's some certain criteria which we need to meet according to the passive house standard. We should use super insulation building envelope. We should use high performance windows with U value 0.8. And we need also to use ventilation with heat recovery system and provide air tightness layer around all the building. This is for this 4 main criteria will achieve a passive house classic. But if we add more renewable energy to produce not less than 60 kilowatt hour per square meter per year, we will achieve zero energy building under passive house plus. Again, if we increase a little bit more the renewable energy, we will achieve 120 kilowatt hour per square meter per year, and we will achieve the passive house premium. So passive house plus and the premium, they are zero energy building. In order to start to model a zero energy building or ultra low energy building according to the passive house standard, we should consider the thermal comfort, and consider also the cooling load, the annual primary energy demand, and air tightness. So the main factors which we need to start is looking into how to develop the architecture and the structural model itself, which is we should look into the building shape and orientation, building assemblies for building envelope, footing, roof, whatever, the building envelope, also the window shading and doors, the mechanical ventilation with heat recovery system, and the hot water, domestic hot water. All of this, we should use it, and then we should use also the passive house planning package. The passive house planning package is a static modeling tool which is developed by the Passive House Institute only to achieve the passive house standard. So we need to meet this criteria. So the cooling load shouldn't exceed 15 kilowatt hour per year. The primary energy demand is 120 kilowatt hour per year, and the air tightness is 0.6. The thermal comfort should be met throughout the year, and using renewable energy to achieve the zero energy building. After this one, for the passive house, for myself, I did a validation, and I used the ISVE just to validate the result of the passive house. But it's not mandatory to use the ISVE after the passive house planning package. So this is the model which I created. I created one model, and I tested them in case A and the UAE as well. This model is based on the passive house standard, and I used also the renewable energy source and to meet the criteria of the passive house standard under the passive house planning package. So all assumptions have been proposed based on the passive house planning package design criteria to meet the passive house standards, such as building location, building orientation, area of the windows and the doors located on the north facade for the orientation, using super insulated building envelope with U value 0.5 watt per square meter Kelvin, and for the windows and doors using U value to meet 0.8 watt per square meter Kelvin. Here's the outcome of the two models, which one is based in Dubai and one is based in KSA. The same model, I tested both of them, one time under the climate of Dubai and the other one under the climate of KSA. And both had achieved the passive house standard, and both had achieved also the passive house with the renewable energy to achieve the zero energy building. This is the first one. So the PER energy criteria for the passive house classes, the energy model is represented on the graph by an X to indicate the achieved class in our model. So here it seems that we achieved passive house with low energy building, passive house plus. And we achieved 185 kilowatt hour for the renewable energy generated from the solar panels. For the KSA also, we achieved the passive house plus, and we achieved 77% from the solar panels. There's some steps which we need to take so we can introduce this knowledge to the others. Like we need to provide education and the courses. We need also policy to support us in this specific topic. We need also some climate specific research. We need pilot project because we don't have pilot project. The only pilot project which I saw was in Qatar. We need also to have partnership and collaboration between each other and between other research institutes and we need to work into integrate the renewable energy into our normal grid. And one important thing is to have monitoring and feedback systems which will tell us if this is what we designed is suitable, is working or not. Thank you.
Thank you so much, Dr. Mohamed Mahgoub. Great presentation. Our next speaker, coming from Italy, working in Germany, Mr. Davide Malizia. Davide Malizia. أتمنى أكون نطقت صح يعني. Market development high performance product in Europe, Middle East, and Africa at QIAN, with a strong academic background and huge experience in glass industry. We'll talk about reduction of carbon footprint with structure interlayer. Please welcome on stage.
Thank you. Thank you, Albaraa, for the introduction, and thanks to Zak Association for the invitation. So, as you see on the screen today, we're going to talk about reduction of carbon footprint using structural interlayers. So, showing you how structural interlayers for laminated safety glass can produce optimizations for your glass facade projects and also bring carbon footprint optimization. This is a brief show of how the content of the presentation is gonna develop. So a brief introduction of our group, QIAN group. Then we're gonna dig into the very core of the presentation, so the interlayers embodied carbon footprint. We're not only gonna talk theoretical about carbon footprint in interlayers, but we're also gonna show a case study, which is a value engineering, environmental value engineering, a case study of a project, a real project in Paris, Montparnasse Tower. And in the end, we just wanna show you how everything works, everything that we showed before works, as long as the right product is specified, as long as the right product is implemented into the project. And we're gonna show what's the cost of wrong specifications or wrong product implementation. So quickly about QIAN Group, of course, we're gonna talk about architectural interlayers. So we belong to this division, this segment, but QIAN is a huge group, a chemical group that has many other business around the world. Of course, automotive with the same interlayers that we have in architectural, but also paper and packaging, solar, environmental protection, and so on. So the products that are made by QIAN, you also meet them in your everyday life. So for example, the screen protector for your laptop or for your mobile phone, packaging for food, or many other products like this. All these huge portfolio is brought to you by a global presence made of more than 50 production facilities spread over 31 countries. Okay, there is something wrong. But okay, this shows our commitment towards carbon footprint reduction. So our goal is to meet by 2030, 30% CO2 emission reduction, and we want to hit the net zero level by 2050. All the environmental and sustainability related topics that we're going to talk about today, you're going to find also the necessary material on our website with our brochure, our EPDs. Our brochure includes all the data you need to perform your life cycle assessment, LCA. So if you want to reach any certification towards LEED certification or BREEAM certification, all the data you need about our interlayers, you can find them in our brochures. So let's jump into the core of the presentation. So interlayers embodied carbon footprint. But before we talk about the carbon embodied into interlayers, let's talk about what we actually do in QIAN. This is laminated safety glass, which is no more than a sandwich made of two glass panes with an interlayer, a plastic interlayer in between. And this is the product that we're going to talk about, that is going to be highlighted in green today. This interlayer comes from two main material family, we can say PVB, polyvinyl butyral, and ionoplast based, which is another chemical composition. And we're going to talk specifically about this today because this brings us to our topic product, which is Sentry Glass. This is the embodied carbon footprint that we have in interlayers divided by family. So the first three that you see on the table belong to the Curaray group family product. So PVB, which has an embodied carbon footprint of 3.26 kilogram of CO2 equivalent embodied into interlayer. Sentry glass, which is the other family of interlayers, so the ionomer with 2.64. The products that we're going to launch in Glastic in 2 weeks from now, a very well-known fair in Germany happening now in the end of October. The embodied carbon footprint for these interlayers is going to be lower than 1, so way lower than the other products we're going to show you. But the question here is, how can we reduce the carbon footprint in laminated safety glass? Basically, we see 2 ways. One is to choose an interlayer with lower carbon footprint. So, for example, moving down in the table from a PVB to a ionomer or to a low carbon PVB. But there is also another way. We can work on the structural performance of the interlayer to lower the thickness of the glass, which is most of the times what generates the high expense in terms of carbon footprint. This is the first of the 2 examples. So we have on the left laminated safety glass with a glass total thickness of 16 millimeters. And what we are doing in this comparison is only changing the interlayer. So moving from an ultra clear, a standard PVB, to the green interlayer that you see on the right, a low carbon one. And of course, we see a reduction of carbon footprint of CO2 with a saving of 10.3%. In this case, the structural performance of the interlayer is not changing, so there is no way to have any weight or any thickness saving. But now we move to the second example, which is changing from a PVB interlayer to a sentry glass interlayer. And thanks to the stiffness of this interlayer, thanks to the increased, enhanced structural behavior of this interlayer, then we can actually reduce the glass thickness from 16 millimeters, so 2 8 millimeters panes, to 2 6 millimeter panes with a total glass thickness of only 12 millimeters. This not only generates a reduced carbon footprint, which is even higher, as we see there, 24.4%, but we're also saving in weight and thickness. Now, it comes without saying that as the laminated safety glass is getting lighter, we can also achieve optimizations on the structural elements that are supporting the facade, which can bring as a consequence to further carbon footprint reductions. This is not part of our analysis, it's only food for thought, but you should also consider that. All of this was theoretical. Now let's jump into a practical example. This is Montparnasse Tower in Paris. What you see on the left is the current status of the facade, completed in 1972. It's a very big building, so 60 by 40 meters in plain view, 210 meters height of the facade. The rendering visualization on the right is made by TES, Atelier d'Ingénierie, very well-known architectural and engineering studio based in Paris. The calculations was done in combination by Curaray and TES, Atelier d'Ingénierie. TES found out that 30% of the embodied carbon of the whole building is embodied in the facade only. Now, our analysis has focused on the highest portion of the facade, which is the checkerboard, the pink one, 20,000 square meters. The module analyzed of this facade only the outer layer, so only the outer laminated safety glass, contains 20% of the CO2 equivalent of the element of the module itself. Now, the analysis we want to make is, okay, let's consider that the outer glass is going to be made of laminated safety glass. And as we said, we have 2 options. We can build a laminated safety glass with PVB interlayer or with sentry glass. The comparison, of course, has to be based on the wind loads applying on the building. So as we see, this is on the left wind suction, so negative pressure. On the right, we have positive pressure, so wind pressure towards the facade. We can see that the higher value we have is this one, so minus 3,200 kilopascal, which is the most demanding load applied on the facade. The map we're going to see in the next slide is the comparison between the two cases. So PVB interlayer on the left side, sentry glass interlayer on the right side. How to read the map? Red means thicker. Going towards green and blue means slimmer, so less thickness of glass. And as we can see, not only on the corners where most of the loads are applied, we see more red on the left example compared to the right example. So we move from a maximum thickness of 18 plus 15, so 33 millimeters of glass, to 15 plus 12, so 27 millimeters, with a saving of 6 millimeters of glass. But also on the main areas, we can see that front facades, they go in the left example more from the green, light blue to the bluish and dark blue, which means again less thickness of glass. Overall, this story brings us to this general calculation. So on the left side, we see what we can save by applying sentry glass and what is the carbon footprint embodied in interlays with PVB. So we can see that the difference is approximately a 20% saving using sentry glass. All we said so far works as long as the right product is selected, as long as sentry glass is in your specifications, as long as sentry glass is actually implemented in your projects. What happens though when the wrong product is specified and or implemented? We're going to show this in the next slide. Sentry glass is the only product available on the market that has more than 25 years experience. So none of the other products existing on the market can prove the history that sentry glass can. Sentry glass has been tested in basically globally all around the world. So there are project references from all the climates and all the areas around the world. This cannot happen in any of the other products on the market. And these are the consequences when the wrong product is applied. We're talking often about counterfeited SGP. Often SGP is thought to be the same as sentry glass, but counterfeited SGP is not sentry glass. Sentry glass would not show this phenomenon. This is basically the interlayer cracking. The project was completed, I think, since 3-6 months, and due to high temperature, the interlayer is cracking inside the laminated safety glass. You can imagine how expensive it can be to replace such glass in a new build construction. The examples that you're gonna see here are exactly a comparison between sentry glass, our Curaray sentry glass on the left, and counterfeited SGP. This is a balustrade, 1.2 meters high. This is an impact test with a 45 kilos mass hitting the balustrade. The post-breakage resistance shown by sentry glass is quite evident. So the two glass panes are breaking, but sentry glass still has a post-breakage resistance. So the balustrade is standing. Counterfeited SGP, as we can see, the balustrade is breaking, the glass is breaking, and the balustrade folds like a piece of paper. Again, it's truly important that you select the right product. We are there for you to support you in the selection of the right product, but not only us as people in Curaray, we also have our online tools that can support you. So if you want to scan the QR code that you see on the left, or you can come to our desk later on in the other room, we're gonna show you where to find the tools and the download app that we have on our website. So all the tools that you see on the screen, they're going to support you to perform preliminary calculations, structural calculations, sound calculation, daylight performance calculations, you name it. So, but if that's not enough for you, we also have our technical department to support you. You send us your specifications, you send the characteristic of your projects to us, and we can support you to find the right product for you. Thank you.
Thank you so much, David. Our next speaker is Facade Engineering Manager at Khatib Alami, with extensive experience across Egypt, KSA, Emirates, Libya, Bahrain, and Canada. We'll talk about Jeddah vernacular architecture, building physics, consideration for hot climates. Let's welcome Medhat Saad with warm applause. So.
صباح الخير. أنا مدحت سعد من خطيب عالمي. النهارده حابب أتكلم أكتر على ال vernacular architecture in Jeddah and the current approach أو the current direction من كل الاركتكتس بيعملوه إن هم عايزين to match or at least to copy the architecture, not to copy but at least to match it in a modern way. سريعا انا مش هتكلم في الاركيتكتشر بس لازم ابتدي بالانترودكشن ديت. جدة بوجودها كميناء مهم جدا في المنطقه اتاثرت culturally بدول حواليها كتير، وجودها قدام مصر برضو اثر عليها. احنا عارفين طبعا درجات الحراره في جده، اذا كان هنا في ناس مقيمين في البلد درجة الحرارة ممكن توصل ل 38 درجة. relative humidity can reach 85%. هيبان احنا ليه بنتكلم في الموضوع ده كمان شوية. الحقيقة انه الحجازي architecture or البلد traditional architecture ليها features واضحة. mainly we have stone load bearing stone walls. عندنا مشربية erosion panels. These are timber screens. وده اتاخد من كذا ثقافة زي ما كنت بقول لحضراتكم. الستونز اللي كانت very common بتستخدم في المنطقة كان الكورال ستون. الخشب كان فيه أنواع كتيرة قوي، منها التي كود كان مشهور جدا، وده الأشكال اللي كانت بتتبني بيها الاركيتكتشر في جدة عموما. الصفات الكونستراكشن بتاعت الفساد في عمارة جدة كانت من الحوائط الحاملة، كانت تقريبا بتبتدي بثكنس 70 سنتي 60 سنتي وبعد كده بتبتدي تقل لفوق. كان بيستخدم الجبس ساعات اللايم في البلاسترينج internal and external، والخشب mainly في doors and windows. طيب في سؤال، هو ليه احنا ما نكملش بالستايل دوت دلوقتي؟ ليه ما نكملش باللي اتعمل من 300 سنة فاتوا؟ الحقيقة انه ما ينفعش نتيجة لكذا سبب. Number one, we have construction systems دلوقتي more advanced بتدينا spans أكبر، سواء احنا we are going with a concrete structure or steel structure whatever the system is. ده مش هنقدر نعمله بالحوائط الحاملة. في structural challenges and codes. عندنا wind loads مختلفة، عندنا seismic movements برضو، ده هيدينا a kind of limitation في الديزاين بتاعنا. طبعا نحن نعمل حيطان كلها ستون بالكميات ديت this is not economically feasible. so برضو محتاجين ان احنا نلاقي حاجة تكون من ناحية التكلفة تكون اقل. حتى الديزاين نفسه، لو احنا بنفكر النهاردة ان احنا بنعمل استاد، can we make a stadium with the load bearing walls? It doesn't make sense. Maybe we can make a part بس مش كل الاستاديوم نقدر نعمله بالمنظر دوت. Accordingly we need to find a modern approach. طب ازاي ممكن نوصل؟ طبعا زائد البرفورمانس challenges mainly thermal performance، وده اللي هنتكلم عليه النهارده اكتر building physics عشان this issue has been overlooked for a long time. weather proofing سواء water او air infiltration، والfire performance. fire performance مهم جدا في كل دول العالم دلوقتي بيفكروا فيه. UK بيعيدوا كل تقريبا واجهات المباني عشان موضوع الفاير and building safety act and so on. طيب الحقيقة هل احنا نقدر achieve the same architecture أو the same appearance with a modern technique? Yes, this is an example of مشربية، wooden مشربية. actually it's made of teakwood، تمام. لكن في شغلنا كنا واخدين اعتبارات ليها دعوة بالthermal insulation، بالfire performance، structural integrity، how this مشربية is acting with the primary structure اللي هي متثبت عليه. هي actually acting as a curtain wall. لو حضراتكم باصين هنا هتلاقوا ان في slotted connection ان هي hinged تحت. فالحقيقة ان احنا we can achieve دوت، بس كمان واحنا achieve دوت we should think about other performance aspects. فلو انا النهارده انا بزود thermal performance بمعنى ان انا بقلل اليو فاليو بتاعتي ومستخدم دبل جلاس، there is a possibility ان يحصل نوع من انواع الكوندنسيشن، يبقى الفريم اللي انا هستخدمه دوت لازم يكون drained. الفتحات اللي موجوده عندي لازم تكون protected. لازم make sure ان الديزاين بتاعي مش بس بيميتيت التراديشنال اركيتكتشر، لكن كمان في ادفانسمنت حصلت في الفاساد انجينيرنج فيلد. وي شود كونسيدر ذيس ادفانسمنت، لان كتير من الاركتكتس بيجي يقولوا ما هي اتعملت بقى لها 300 سنه وهي عايشه، مش زي ما كان المفروض تبقى عايشه. فالحقيقه هو ده اللي احنا بنفكر فيه دايما، how to integrate الادفانسمنت in facade engineering مع ال traditional architecture، لان هو ده الابروتش. احنا مش عايزين نغير شكل جده، مش عايزين نغير شكل اي مدينه احنا بندخل فيها. الشطاره ان انت تعرف تعمل دوت. ده another example لبروجكت actually في جده، وكان الابيرنس بره ان احنا عايزين نستخدم شكل الحجر الكبير دوت كانها حوائط حمل. ف at the same time عندنا challenges ليها دعوه بالثيرمال بيرفورمانس، ليها دعوه بالميه، بالدرينج. فرحنا لسيستم هو موجود من زمان قوي، هاندسيت ستون سيستم او ميسونري ستون. اتس ا كافيتي وول سيستم. عندنا شيلف براكت سبورتنج الستون سلابس، عندنا كافيتي ورا الكافيتي ديت عندنا ثيرمال انسيليشن فويل فيس سو اتس ا ليتل بيت بروتكتد. عندنا باك اب وول عليها ووتر بروفنج. At the same time we are incorporating التكنيكس الصح ان احنا to drain الكافيتي ديت and make it ventilated. والappearance في الاخر بالنسبه لنا طلع تقريبا هو ما عدا شويه حاجات بيتلعب فيها، زي مثلا موضوع خد مننا وقت ويبدو ان هو صغير، بس موضوع الجوينت، الفيلر، المورتر اللي هتتحط. what kind of filler we are going to use. هنستخدم سيمنت مورتر ولا لو الكلاي مورتر او تايب اس مورتر in order not to react with the stone، لان ده كان لايم ستون. anyway ده كان شكل السكشن لنفس الديتيل اللي احنا we developed for that project. طب ايه الادفانتجز؟ سريعا كده، اذا انا بحسب اليو فاليو فور اكزامبل از ثيرمال، لان احنا النهارده نركز على الثيرمال، لحيطه معموله ب كورال ستون سمكها 60 سم. في تيست اتعمل ساسو عملته as per ASTM C518 للثيرمال كوندكتيفيتي اوف كورال ستون. طلع ده الرقم لما حسبناها، طلع ان اليو فاليو بتاعت الحيطه ديت تقريبا هتوصل ل 1.06 وات بير متر سكوير كلفن. compared للكونستراكشن الجديد اليو فاليو بتاعتنا 0.271 وات بير متر سكوير كلفن. This is a huge reduction in U value. ونقدر نوصل لاقل من كده كمان. يعني احنا لو عاملين هي هنا الكافيتي ديت دي تعتبر slightly ventilated cavity. if it's a ventilated cavity اليو فاليو ديت هتقل لحد مثلا 0.15 او 0.16، مش عايز اقول رقم، بس احنا عملنا لها اناليسيس وطلع اقل بكده بكتير. بس احنا مضطرين ان احنا نروح للشكل ان احنا عندنا ال joints grouted. طيب فمبدئيا كده وسريعا، بما ان احنا دايما وقتنا بيبقى قليل فانا جريت بسرعه، بس ايه الهدف من دوت؟ كان الهدف من دوت ان احنا we can achieve ده بمودرن تكنيكس، وكل حاجه ليها التشالنجز بتاعتها ممكن تتحل. طيب ايه البيلدينج فيزيكس كونسيدريشنز؟ مينلي اي فاساد انجينير او اي حد concerned in facade engineering field should have some sort of experience about building physics in terms of thermodynamics, fluid dynamics, to understand the behavior of air, to understand the behavior of heat, what kind of heats we have, ازاي الحرارة أصلاً بتتنقل، سواء conduction, convection, radiation, what are the differences between these. فالنهاردة هنتكلم على الحاجات دي سريعاً، هنهايلايت كم حاجة، بس هنتكلم مينلي على ايشيو عادة الناس ما بتركزش فيها في الهوت كلايمتس وهي الكوندنسيشن. طيب اول حاجه في الثيرمال بيرفورمانس لما هنيجي نتكلم هو الحراره، سواء هيت لوس او هيت جين. تعريفات دايما هتلاقوها يمكن لو جايه من بره هتبقى هيت لوس، لان هم بيعملوا heating inside the building and the outside weather is cooler. هو الهيت جين. الفاكتورز اللي بتاثر في الهيت لوس والهيت جين طبعا هو الهيت فلو اللي هي كيو، الاريا بتاعت الواجهه نفسها دلتا تي. دلتا تي is the difference in temperature between inside and outside environments. So these are the main factors. بس عايزكم حضراتكم تقروا ال definition ده. On a winter night, the ratio of heat loss gain to the area and temperature difference tends to be reasonably constant and is called the U value. Why did we mention in winter and night? طيب, there is a misconception. I don't think إن حضراتكم يعني عندكم هذا misconception, بس هقولها وخلاص. إنه في ناس بتتلخبط كتير قوي between U value and G value. إنه ممكن لو مكان متعرض لشمس جامد اليو فاليو نحسنها عشان تقلل الحراره. This is not correct. اوكي, يو فاليو احسن تعبير ليها ان انت تتخيلها بالليل. العامل اللي بيأثر فيها فرق درجات الحراره. هنا دي comparison سريعا بس كنت حابب ان انا اقولها. اليو فاليو هي بتميجر الهيت ترانسفير through a material. اوكي, من الاخر هي الانسيوليشن. تمام, between اي حاجه وحاجه, between ايا كانت الماتيريال. اما السولار هيت جين, solar heat gain coefficient or G value, which is the more accurate term. The definition solar heat gain refers to the amount of solar energy اللي هي بتعدي اللي هو sunlight بيدخل خلال a translucent material. فما عندناش shading coefficient لsolid material. It's always about translucent material because solar energy can pass by transparent material and come inside the building and generate a long wave after hitting a body. من الآخر عشان نعرف نميز ما بين اليو فاليو عادة هي الحرارة اللونج ويف, الجي فاليو هي الشورت ويف. تمام, خدوها الصن شورت اس و اس. اوكي, أنا حافظها كده عن نفسي. طيب, anyway, condensation. هو إيه الكوندنسيشن؟ What's condensation؟ إمتى بتحصل أصلاً الكوندنسيشن؟ كلنا عارفين, وبالذات اللي عايشين في جدة ولو بيلبسوا نظارات هيبقى قاعد في العربية ومشغل التكييف وبينزل في الصيف يلاقي النظارة شبرت. ده الأكتر تعبير للكوندنسيشن. والحقيقة إن الكوندنسيشن بتعتمد على شوية حاجات. درجة الحرارة الداخلية والخارجية اللي هي درجة الحرارة الباردة والسخنة, relative humidity. تمام, واللي بيحصل ان الهواء السخن اللي شايل بخار ميه اول ما بيلمس سطح بارد بيحصل ان البخار الميه ده بيتكثف على السطح ده ببساطه. طيب, نعقدها شويه. ماشي, relative humidity. relative humidity هو كميه الرطوبه اللي شايلها الهواء compared للماكسيمم اللي يقدر يشيله عند نفس درجه الحراره. ايه, تمام, هي كميه المويستشر اللي شايلها الهواء دلوقتي compared للي يقدر يشيله عند نفس درجه الحراره. That's why اسمها relative humidity. It is not a humidity. اوكي, لما بيحصل ان الهواء بيسقع RH بتزيد, بيحصل ان يعني بيحصل ان في less moisture, ولما ال RH بتريتش 100% معنى كده ان الهواء خلاص مشبع تماما ببخار الميه, ما يقدرش يشيل بخار ميه اكتر من كده. طيب, الديو بوينت, ودايما بنسمعها الديو بوينت هي temperature. الديو بوينت هي درجه الحراره اللي عندها الهواء بيوصل لل 100% RH. تاني, هي درجة الحرارة اللي الهواء بيوصل فيها ان هو مشبع تماما بالرطوبة, بعدها خلاص هيكوندنسيت ومش هيقدر يمسك نفسه اكتر من كده. خلاص ده اخره. اوكي, طيب, فدي ديو بوينت. هنقول ليه يعني انا بقول الحاجات دي. طيب, اذا بيلدينج سيرفيس في البيلدينج وصل لدرجة حرارة الديو بوينت, تمام, وكانت الار اتش احنا بنجيبها من السايكرومتريك تشارت اللي هي دي حاجه اسمها سايكرومتريك تشارت. اوكي, فيها الدراي بالب, ويت بالب, والبرسنتجز بتاعه الار اتش. اللي بيحصل ان الهواء لو وصل لمس الهواء اللي شايل بخار الميه لمس سطح ساقع هيبتدي يتكثف عليه زي ما قلنا لحضراتكم. درجه الحراره سطح حاده لازم تبقى عند الديو بوينت او اقل منها. طيب, ده المنظر ده اسمه surface condensation اللي احنا شرحناه ده كله. However, surface condensation is not the most dangerous mechanism ممكن يحصل لنا. لأن surface condensation عادة هيحصل يا إما في السيرفيس الداخلي يا إما في السيرفيس الخارجي. مش دايما أحسن حاجة, بس we can handle it. المصيبه لما يحصل حاجه اسمها interstitial condensation. الانترستيشال كوندنسيشن من اسمها هي الكوندنسيشن اللي بتحصل within the wall layers. الاعتماد هنا مش مينلي بس على الديو بوينت. احنا عرفنا امتى بتحصل كوندنسيشن. بتحصل كوندنسيشن لما الهواء اللي شايل المويستشر الكبيره دي بيمشي وفجاه يقابل سطح ساقع درجه حرارته عند الديو بوينت او اقل منه، خلاص سهله. هنا في فاكتور تاني دخل ابتدى يلعب معانا اسمه فيبر ديفيوجن. وكل ماتيريال في الدنيا diffuse الفيبر او الفيبر can pass through in a specific rate ما عدا الازاز والميتال، دولت اللي ما ينفعش يعدي منهم فيبر، دولت the only materials. فالحقيقه في الانترستيشال كوندنسيشن الخوف اللي بيحصل ان الفيبر يعدي من منطقه البريشر فيها عالي لمنطقه البريشر فيها اقل ويفضل ماشي 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 لحد ما يلمس سيرفيس درجه حرارته عند الديو بوينت او اقل. In this case هتحصل condensation. In this case هتحصل condensation within the wall assembly and we will not see it until a failure will occur. Hopefully مش failure، ممكن يبقى mold growth، لكن هيحصل failure. مش شرط طبعا عشان ابقى accurate، لانه في الحسابات يعني QIAN 13780 تقريبا او 13700 بيحسب الكوندنسيشن هتحصل وبيحسب الايفابوريشن بيريود. ف sometimes we allow for interstitial condensation in case there is an evaporation period هتحصل. المهم يعني عشان ما نعقدش الموضوع لانه هو معقد شويه. الحقيقه انه ان الاسبكت ده مهم جدا واحنا يعني بنهمله. It's overlooked في الهوت كلايمتس. هم معروف ان condensation risk assessments are carried out في UK في كندا في أي دولة فيها cold climates but in case in a hot climate no one will carry that assessment. الحقيقة إنه بيحصل condensation عندنا في الهوت climates مش زي بره. بره فرق درجات الحرارة بيبقى كبير. لو أنت في كندا في ألبرتا درجة الحرارة ناقص 38 درجة، ممكن جوه تبقى 23. الدلتا تي كبيرة جدا. relative humidity can reach 100% أو 90% most of the time. احنا بقى بتحصل عندنا كوندنسيشن امتى؟ هم بتحصل عندهم في الشتاء، احنا بتحصل عندنا في الصيف في اوجست specifically في جدة I'm talking about. ده شكل الكوندنسيشن. يعني انا عندي layers مثلا من بره لجوه، ده شكلها. ممكن كوندنسيشن تحصل في نقطه في النص وافضل انا قاعد مش عارف ايه اللي بيحصل لحد ما يحصل degradation. خلينا نتكلم على اكزامبل واحد من المشاريع اللي احنا كنا بنتكلم عليها. المشروع دوت كنا مستخدمين فيه insulated blocks which a trend right now ما اعرفش ليه. وعندنا هنا sliding door and we should provide a sort of interface to support the sliding door at the jam connection. Definitely we cannot depend on the thermal blocks لأن هم الcompressive strength بتاعتهم قليلة جدا. They are not structurally really good. So we thought about adding a steel element and continue the insulation line. And this is the thermal line. We call it the thermal line. دايما أي facade engineer شغال على ديتيلة. الحقيقة مش الهدف إنه يحط المسامير ولا يعمل الأشكال الخزعبلية دي. الهدف أكتر إن هو to make sure that the performance is met. الكرايتيريا اللي هو حاططها شغال. لما عملنا thermal analysis لقينا ان ده البرفورمانس بتاعنا. اليو فاليوز بتاعتنا كانت 0.5 عند the most critical part. معظم في الحيطه العاديه 0.198 بيرفكت. حد ممكن يتخيل ان المنظر دوت ممكن يحصل كوندنسيشن؟ unlikely. يعني ما فيش حاجه تقول لنا لا. however احنا عشان احنا معقدين شويه رحنا احنا عاملين لنا هايلايت بالاحمر كده على درجه الحراره، ده بنسميه ايزوثيرم لاينز، عند درجه الحراره اللي هي الديو بوينت. لما جينا عملنا ده هنا كان اوبشن القديم اللي هم بيستخدموه ان هو يعمل زي كونكريت جامب كونكشن. وطبعا البريدجنج باين، يعني الثيرمال بريدجنج باين في الحته دي مش محتاج اشرحه، فطبعا ما رحناش للاوبشن دوت. دي اللايرز بتاعت الحيطه، ده السكشن برضو الثيرمال اناليسيس. لما جينا عملنا الهايجروثيرمال اناليسيس اللي هو الكوندنسيشن ريسك اسسمنت، لقينا انه actually بتحصل condensation عند آخر البولي ستايرين اللي XPS اللي موجود. يعني احنا لو حضراتكم رجعتوا بيحصل فين؟ بيحصل عند الخط، أنا مش عارف أصغرها إزاي، بس هو بيحصل عند الخط ده اللي جوه ده. دي الاناليسيز، لان الكوندنسيشن بتحصل في اشهر جولاي اوغست، طبعا the most significant one in August, September, October, and evaporates starting from November till March. وده حاجه اسمها جليسر دايجرام، بيبين علاقه الساتوريتد بريشر بالبارشال بريشر. مش عايزين ندخل فيه، انا بس بحاول اشرح اهميه ان الموضوع ان ممكن تحصل حاجه زي كده. طب احنا حليناها ازاي؟ ببساطه احنا حطينا فيبر كنترول لاير. احنا قلنا ان في فاكتور جديد ابتدى يلعب معانا اللي هو الفيبر. مش عايزين الفيبر يعدي جوه، الديو بوينت تيجي، بس لو ما فيش فيبر خلاص حطينا فيبر كنترول لاير. حطينا فوق الفيبر كنترول لاير انذر تشيكن ميش او مش يعني بي في سي سوري فايبر جلاس، وبعد كده حطينا الاكسترنال ريندر عليها. another example حاجات برضو بتحصل وبرضو حضراتكم خلوا بالكم منها وانا كمان محتاج اخد بالي منها، انه بعض الاوقات ان احنا we copy details or specifications coming from outside and we put it here in our environment, and this is totally incorrect. أنا في مرة كنت في زاك مصر وقلت كلمة إنه إحنا كلنا عارفين إن إحنا بنكوبي السبيسيفيكيشنز، كلنا عارفين المعلومة دي، وبقينا نكوبي الديتيلز كمان، يعني مش بس السبيسيفيكيشنز. أنا في مرة كنت براجع على مشروع ولقيت حد حاطط بريثر ممبرين في الامارات، يعني جوها قريب من جونا، اللي هو بتعمل بريثر ممبرين ليه؟ حضراتكم عارفين البريثر ممبرين؟ اكيد حضراتكم عارفينه، خليني اتكلم عليه كده سريعا. بريثر ممبرين عباره عن ممبرين معقد جدا بيسمح للفيبر انه يعدي منه، لكن ما يسمحش للميه انها تعدي منه، وبالتالي يعتبر ووتر بروفنج ممبرين. بس امتى يعتبر ووتر بروفنج ممبرين؟ يعتبر كمان فيبر كنترول لاير، لانه بيسمح للفيبر انه يعدي، فهي اتس كنترول لاير. وات كايند اوف كنترول ده another story. فهو ووتر بروفنج ممبرين فيبر كنترول لاير، هاويفر مش لينا، مش بتاعنا. الهدف من البريثر ممبرين اكشلي هو بيتحط في الكولد كلايمتس، اللي هتلاقيه فيري كومن ان يو كي، ان هم بيعملوا هيتنج جوه ودرجه الحراره بره هي اللي ساقعه، فالفيبر دايركشن جاي منين؟ من جوه لبره، تمام. فالبريثر ممبرين ده بيعمل ايه؟ يخلي الفيبر يجي من ظهره، يجي يروح مطلعه لبره. اول ما يطلع بره يقابل مين؟ الكافيتي. الكافيتي درجه حرارتها واطيه جدا، يحصل له ايه؟ كوندنسيشن، يكوندنس على مين؟ على البريثر ممبرين. يجي يقول له انا عايز ادخل تاني، يقول له مش هتدخل، انا طلعتك. فايتس فيري سمارت كايند اوف برودكت، بس مش بتاعنا، ما حدش يستخدمه. يعني ممكن لو حد عايز يشتريه ويتفرج عليه، بس ما حدش يستخدمه في كافيتي. الحقيقه ان اللي بيحصل عندنا العكس بالظبط، درجه الحراره بره هي اللي سخنه، هو ده الفيبر جاي من بره، هيوميديتي جاي من بره، بتدخل تعدي البريثر ممبرين، تدخل عند الانسليشن، it may condensate there and trapped, totally trapped بقى. يعني انا لو كنت سبته من غير حاجه كان هيبقى احسن، انا كده عملت trapping للميه. فdefinitely this is a kind of technique that should not be يعني considered in our construction, specifically احنا we are acting in a hot climates. ده الاكشن اللي كان هيحصل لو احنا استخدمنا بريثر ممبرين قدام الثيرمال انسوليشن في نفس الاكزامبل اللي اتكلمنا عليه بره قبل كده، سوري، انه الهواء هيخش هنا السخن، هيخش يقف عند البريثر ممبرين، هيقول له يخش في الحته دي، condensate and it's trapped forever. طيب الكونكلوجن عشان طولت عليكم وتعبتكم. الهدف من اللي انا كنت بقوله النهارده مش ان انا اعرض شغل ولا اتكلم على حاجه، بس في ايشوز لازم نخلي بالنا منها. building physics considerations are really important. ان احنا to assess our details, to assess our jump connections, to assess the cell connections, make sure ان احنا ما عندناش bridging and weak points, to check الابساي والكاي, whoever working in the field will understand me, to make sure ان ما فيش linear bridging, repeated thermal bridging. Condensation risks are likely to occur in hot climates, specifically in summer. So we need to make a condensation risk assessment. مش بس external facade, by the way, internally كمان. Sometimes if we have a parking, إنه عندنا electrical room متكيفة وبراها الباركينج مش متكيف، ممكن يحصل condensation. فدي الكونسيدريشن لازم نخلي بالنا منها. selection of material is very important. بلاش نستخدم materials احنا مش عارفينها او membranes احنا مش عارفينها ومش عارفين هي بس بتتباع على اساس انها waterproofing membrane. ونحاول على قد ما نقدر ان احنا to optimize the performance مش to increase the performance. And there is a big difference between them. انا مش عشان اعمل مبنى كويس لازم اخلي اليو فاليو اقل حاجه واخلي الشيدنج لا مش شرط. Relax the specifications but think smartly about it. Thank you everyone. شكرا لكم.
مدحت. شكرا باشمهندس مدحت. Exactly on time. Our last speaker before break time from China, Miss Nancy Wang, the director of the International Sales Department of the Glass Deep Processing Division of North Glass, with over 20 years of experience in glass industry. She will talk about the key factors of architecture beauty. Please welcome on the stage.
Okay. Good morning. Nice to see all of you here. Yeah, thanks for the organization of DAC and thanks for the introduction. I'm from North Glass, so I will do a short introduction of North Glass Group. So North Glass was founded in 1995, and we have different locations in Luoyang, Shanghai, and Tianjin in China. So we have two main products. One is glass machinery, another one is processed glass, like 24 meters glass or some curved glass in small radius, or like 3D curved glass. So today I will give a presentation to show that for the glass division and how to bring our glass technology to the buildings to make this building to be unique and special. So I will show some projects as example. So here shows our processing capability. The maximum size we can produce is 24 meters by 3.3 meters. We have our coating machines and tempering machines. And also here we can produce like 3D curved glass in 12 by 3.3 meters. Then we show some extra large glass application for the buildings. So the first one is what we have supplied the glass to Apple, which is in China, in Sanlitun. The glass is 12 meters and 110 millimeter in thickness. So you see that the facade is totally glass and without glass fins. So it can save the space inside of the room. So this is the first one, which is just 12 meters. But the second one is the Beijing library, which is 16 meters. And it's 10,000 square meters structured glass for this project. And the glass thickness is 135 millimeter. From this photo, you can see that after the glass installed, it's like a zigzag. So it's like more than 30 different angles for the edge. The edge are all the bevel edge. And for this project, also without the glass fins. Yeah, here is the next one, the Qatar Tower, which is 16 meters. We transport the glass from China, Tianjin to here, to Qatar. The next one is the Taikang Tower, which is 17 meters. The architect is PCPA. We got the Guinness World Record for this project. During that time, this is the biggest glass in the world. But now, it's not the biggest one. So here is another job reference to show, which is 17 meters as well, but it's a horizontal installation. So this is very good to use for some villa or some private house or some showroom, because there is no joint. Yeah. The next one is the Guangzhou Commercial Center, which is the largest glass in the world now, which is 23 meters. And you can see the people stand there. That is a mock-up, and the right side is the finished glass. Okay. So now I think for all the people, the client or the architect and the consultant, they concern more about the flatness of the glass. So North Glass has our own tempering furnace. We produce a tempering furnace. We use our own tempering furnace to produce the glass. So we have our own technology to control the flatness of the glass. So here shows, there is a table there to show the comparison of our tolerance with the ASTM and the QIAN standard. So you can see the ball tolerance and the roller wave tolerance is much better than the ASTM and the QIAN standard. And also the right photo, you see the reflection of the glass also shows the flatness is very good. So all the glass in our factory produced by our top series tempering furnace. So this tempering furnace is very advanced series in our North Glass group. So you know, for the tempering processing stage, in order to make sure the flatness and the anisotropy, the very important is the cooling stage. So during the cooling stage, for some normal tempering furnace, maybe the glass just move out. But for our furnace, during the glass move out, the quench also move from left to the right to make sure that the cooling wind is uniform on the glass, to make sure the flatness and the anisotropy quality is the best. So this project is Huawei in south of China. So you can see the reflection is very good. Yeah, here are some other projects as well. The left one is the two telco plants project in Hong Kong. After the glass finished, the client went to the job site to check his glass to compare with others. The flatness of this building is the best one in that region. Yeah, here is the mobility pavilion in Dubai. The glass, which is 4.5 meters in arc. It's a kind of curved glass. And also this one is Abu Dhabi International Airport, which is 100,000 square meters glass. So the next is for the curved glass. So North Glass produced the single curved glass, large arc glass, small radius glass, and 3D curved glass to produce different geometry for the buildings. So this one is a single radius curved glass job reference, which is Apple Park in Cupertino. The glass is 17 meters. It's a sliding door. So this door totally has 40 pieces glass. The two sides has 20 pieces fixed panel. So for the sliding, two panels sliding, each side with 10 pieces glass. So this door is very heavy. It's like almost 100 tons. So here is the next one, the Shanghai IFC. In fact, this is a rebuild project. The old one was in 2010, but it's rebuilt this year. The old one with the glass fins and beams, but this one without fins and beams. And the roof is totally a 3D curved glass. Yeah. So it's after this glass finished, because it's no fins and no beams, so sometimes the client is asked, how to make this structure. Yeah. So, and after finished, we got the feedback from client. Yeah, this is a new landmark of the curved glass in the world until now. This is a Dubai Mall Apple Store, which is 12 meters. It's a single curved glass with the coating also from ourselves. Yeah, we have our coating machines with 18 meters. Okay. So here is another project with curved glass as well, but it's a concave curved glass. All the glass are concave curved with low E coating. So, for concave glass with low E coating, the very critical is during the tempering stage, we need to make sure that the coating is not touch the tempering ruler. So because North Glass produce a tempering furnace, so we have our technology and such kind of the furnace to produce the concave glass and make sure that during the tempering stage, the coating is not touch the ruler without damage. And the middle panel, the top middle panel is a 15 meters arc-length curved glass. So this project shows the small radius glass. So the minimum radius we can produce is 100 millimeter. This is a national speed skating hall. Yeah. You see the glass makeup is like 6 millimeter laminated glass with screen printing. Very important is the glass is heat strengthened. So maybe some factory also can produce such small radius glass, but very important to make sure the glass is heat strengthened. Otherwise, during the temperature change, the glass may be simmer break. So here is another job reference with a small radius glass. The project located in Shanghai, the glass radius is like 175 and 125 for this project. This is a 3D curved glass job reference, which is the Shenzhen Opel headquarters. So for this project, there are 80,000 square meters, but 40,000 glass are 3D curved glass. Yeah. Here is another project, the New Performing Arts Center. This is a rendering. So you can see from the rendering that some glass concave, some glass convex. This project is finished installation. And you can see from the left photo, the reflection of the glass, the distortion of the glass is very good quality. Yeah. Here is a Huawei Red Beam project. All the glass are 3D curved glass. And every panel are different. So here are the photos after installation. Yeah. Here is the backside. So for the 3D curved glass, the very important is the coverage of the glass. When we produce the glass, we have our technology to control the coverage. And after the glass finished, we use the 3D scanner to scan each panel of the glass to make sure the coverage is correct. So here is the photo after installation. So you can see the label panel, every label panel are matched perfect. So here is another job reference, the Cartier in Miami. I take the left two panels as an example. So the top panel, the top edge, which is convex, but the bottom edge is straight. For bottom panel, the top edge is straight, but bottom edge is convex. So after finished, the glass, the top of the glass is flat, but gradually changed to the bottom, to the curved. And this glass is heat strengthened glass. We can do such 3D curved glass in heat strengthened and tempered. Okay. So here is another job reference in Qatar, the Lusail Tower. We produced the podium glass, which is the 3D curved glass as well. you can see from the drawing that the left color is maximum like 400 millimeter rise. So after finished, the glass is like a twist. Okay. Also, we bring our new product today, which is a cast glass. So for the cast glass, we can produce the maximum size in 6 by 3.2 meters. The thickness can be different, like from 20 to 200 or whatever you want. Okay, so that's all for my presentation today. Thank you very much.
Thank you, Nancy. Okay, finally, let's take a quick break to grab some tea and, of course, chatting with and networking with the audience. It is a great chance to network, and please, if you have any questions during the presentation, you can ask the speakers directly. The break will be 20 minutes, and we will resume the conference at 11:30 sharp. Please, in the next hall. Thank you. طيب هنبدأ تاني. I hope you enjoy this break and get back your focus and energy. Starting the second session, our next speaker is مهندسة أو معمارية ولاء عداس, Urban Cultural Design Manager at GCD, شركة وسط جدة, a Saudi city planner, architect and designer with over 15 years of experience and master's degree in architecture design from UK. She will talk about architecture design, architecture facade design between past and future, a semantic facade between cultural and architecture design. Please welcome on stage.
Thank you. Thank you. Hi, everyone. I am Walaa Addas, cultural architectural designer, and I am so happy to see that as an architect, we are no longer giving hard time to engineers building great facades then, seeing glass productions giving us all the curves that we need. Today we will have a I'm trying to keep it short because this topic is a bit theoretical. Coming from an academic background, we would like to highlight a language between cultural facades and the urbanism, facadism that we are going through in a contemporary rapid speed days. So my quick agenda is that we will go through an introduction about culture and conservation, why adaptive reuse and values behind cultural facades and sustainable innovation approaches through research and applications. And we will mainly focus on a local context that is Jeddah city. So heritage, as you know, it plays a vital role in facades. So when we travel around the world, we visit many historical sites, and it gives us a language of community, people, time, economy, status, regality, power. That's why there is a great connection between the facades and the interior. So during the 21st century, during the movement of post-industrial revolution and the Bauhaus in facadism, which is a deconstruction of details, it kind of affected the value of culture somehow, where people wanted more functional buildings, where it booms on a building block level. So today I'm going quickly with the answer on how to enrich our cultural facade by conservation. And it actually plays a two-in-one, preserving our past and developing our future. And a lot of people would ask why. Why do we want to have a facade that is representing identity? Why is that important? It's actually a question that it's a preference actually from an architect to another, but culture itself has a very great role in not just serving an aesthetic facade, but also it maintains an identity. And we are all different. So when we say you are a cultural person, you are a person who have been visiting, understanding many different regions, languages. And this language in particular, what an architect should understand also to represent a facade. This is morely a brief about heritage and conservation, and it's what are these in terms of roles in architecture, preserving the identity of cultural facades. So for me, I came to a conclusion that a cultural facade has to come from the past and through the norm and stand of a community daily activities. So it is designed by people for the people. And we have to look through methods when we look into conservation, which is the conservation or a demolition from, it depends on this scenario of a zone. I'll take you quickly to Al-Balad scenario, and we will have to look into the integration between the facades and the public realm. But to look generally on conservation, it is, there are lots of methods. We start with an example of preservation, which is just to protect an old image. And then we have a restoration and regeneration. It means the building is still able to survive, but you are completing its image. Renovation, it morely comes in the interior design of the space. Reconstruction, it's mainly a rebuild. Adaptation is to transform the use or the function of the old building. Maintenance is enormous work of preserving the look and feel of the facade. Replacement is definitely bringing new and old fabrics together. Demolition is the last method where you would want to eradicate an old unfunctional building. So we're talking about cultural language today, and we'll definitely be speaking with heritage. Imagine what is exactly heritage. It's like a person today who's meeting his great-grandparent maybe 300 years ago, and how would this conversation between you and your greatest grandfather would be? It would be interesting, actually. That's why some people say, why heritage? Why reflecting back on past? Why shouldn't we just move on with innovation and technology? But it's what makes it really interesting is to tackle cultural roles through community and to reflect the time that has proven a society and a community part of the flourishment of a place. So reuse is the only answer on how to keep up with the cultural context in the urban and the technology speed we're living in. One of the great successful answers also is adaptive reuse, and it's significantly has proven that since the ancient time of buildings that we've seen, whether in Greece, Roman has been transformed actually their temples into, for example, basilicas. And from there, the idea is not very new, it's quite very old. That's what when we visit Europe today, also the lavishness that we see since the Renaissance time, it resembles also a powerful state on their facades. So facade works as an aesthetic image, but at the same time, it's also a shelter from climate hazards such as wind, rain, and so on. So once since we were students actually in masters, we were told that once we want to study facadism, we have to integrate the facades with the public realm, public fabric, and start to stitch these surroundings together and see what is exactly missing to fill in the void. So what we see interesting today is the adaptive reuse, which is purposing buildings as they were and then stitching new into old, and that is definitely fine if you are only respecting the surrounding, working on materiality, which we'll be discussing, on how materiality actually is the major or significant part in identifying a cultural facade. So this is one of the famous projects by David Chipperfield in Berlin, Germany. And it's actually in the 20th century where it was, I think, partly in the middle demolished through the World War, and then there had to be an adaptive reuse of the army building into a museum now housed and then the center part here it was exactly built to fit in between the old and classic facade into a similar material in terms of pattern, look, and color, but it does kind of try to imitate the old longitudinal windows, but in a very simpler, modern lines. And you can see even the stitches of the material here coming from the old bricks with the new finish of stone. And this is considered a restoration project that is a precedent for us today to learn and how to renew the image of the old, yet in a very contemporary approach, keeping and preserving its identity. So this is the interior of the museum, keeping the old bricks in Germany, but still try to keep it a very clean, whitewashed finish, so you don't feel that the building has much changes in the inside. And this is what makes facades really interesting when you go to classics and historic sites, that you have this connection that you start to have questions, yet you get answers in every corner. You understand that the exterior is really very much meticulously designed with the inside. This is another project in China, Shanghai, and it is a mixed-use building, and it's also has been went into adaptive reuse architectural facadism, but still the completion of the project had to somehow imitate the same color and material-wise. The windows started to look almost the same of the old fabric. So this is almost looking into kind of different precedents that somehow shows how we can renew the old structures. This is another project, but it's in Berlin. Berlin, actually, one of the cities that can give you a great precedent studies in how to renew the old structures due to the World War, and how did they actually took a role in cultural facades. And with the new technologies that today we've been hearing about glass, it's a great alternative to give openness. Still, when we want to discuss about Jeddah now, I will take you through just old and new, where you have to kind of imitate the same look and feel. And here's another example with a contrast, where this is a factory mill in the UK, and they have inserted a kind of chrome material in the center of the chateau because of the actual function of the factory that is manufacturing chrome. These are just images showing a rebuild to reconstruction on how to put an old facade in conservation level through adaptive use as well. Means you could be able changing its use. This is old coming with new, and this is also an old coming with new facades, but this is more of a stitched new material coming into old. This is a station in the UK as well, where the classic cathedral comes with a glass-built gift shop next to the train station. And this is the latest example I have seen where glass meets with stone, which is a contrast in texture. So we are going back to value of sustainable culture, and sustainable as well plays the major role in cultural facades. Because what we've seen today in so many great projects coming in the kingdom, such as Al-Ula, we have to preserve our heritage, inserting a great contribution of a modern aesthetics. Still, it is a representation of the users, and that's what makes it interesting, this combination of environmental benefits approach within heritage preservation. Secondly, we have a reuse, which is Al-Balad development that is representing a reuse of these old buildings, whether it's a reuse on the same sort of function such as residential, because mostly the housing and Al-Balad are residential project, so it is transformed into more of a accommodation such as hotels. So by cultural facadism, we are empowering local authenticity, and this is where we, as a community, we aim to honor this legacy and the historical background where we come. Jeddah in particular is a very cultural city because it comes from a multi-regional influence, whether it's Egypt all the way to India. But the interesting thing here, if I want to discuss Jeddah today and looking at its Roshan facades, as my colleagues earlier talked about, wood is not a sustainable material in Jeddah, nor an affordable material. We are not a forest city. We don't have forests. We don't produce woods. These were all coming through the Indian Ocean towards the Red Sea with great skills. That's another topic. And if we want to talk about sustainability today, we need to look into having a local source material. It will bring efficiency in finding these materials, transporting these materials, and working with them, definitely. But to look into what exactly was sustainable that time is definitely the coral stone, Al-Hajar al-Mangabi, and finding that in a very adjacent source next to Al-Balad, it was very much easy for them to carry it and work with it. Definitely, they've been working with architects, not contractors who had done these housings, and definitely when we will see the barahat and the sikkas have all been meticulously designed to respect the surrounding, where also culture has a great influence from religion, which is privacy. And one of the great factors as well is the environment, which is the sea. So today we have a lot of great factors that I will discuss on where we exactly can get our inspiration in materiality. So if we want to talk about a quick background of Jeddah, Jeddah is one of the historical cities in the Red Sea, and it was actually a town, a group of fishermen in a village who lived in a town, and that was like more than 1,500 years. And then with the beginning of early Islamic time, the Khalifa Uthman bin Affan built the mosque in Jeddah town for the pilgrims who used to come and transit to go to Mecca city, because Mecca was a city, Medina was a city. So this town is very much more of a smaller scale town who had their startup facadism from the merchandise that comes all the way coming from the Red Sea. So the gates, actually, it's by itself, it's a representation of how the facades started to take place through the arches and the coral stone. And this is by itself is where we are adapting today our facades of Jeddah and building our identity, which I believe only from the material that we find in the area. Although coral is no longer a very much affordable material, but it can give a very much fetish sort of linkage to Jeddah, as it's a coastal city. So cultural facades comes from history, comes from culture. Of course, it's the norm of people, how we dress, we eat. So it's very interesting to look into cultural facades. It tells you as the tradition and the level of how conserved, how open people can be. What is the language that you would understand these people through their facades? Actually, it's an exterior design. It's like you're looking into buildings as if you're looking at humans, how they dress. So actually exterior designs and facades, it's the image of the building itself. So we will take culture actually by, as I said, stitching all the images together. So once you have trying to construct this image, you will start to understand and analyze the voids in between the buildings, which is a complete picturesque. You will understand through windows and doors and roshans, and also going through material sustainability. So in any project that we start to design for Jeddah today, we look into the urban development of Al-Balad. We look into how we can conserve this heritage. And from there, we build different terminologies, whether it's for tourism, it's a type of land use, and how local municipality can obtain guidelines, rules and regulation from Al-Balad and to spread out all around the city, but with the modern interpretation for sure and with the Saudi code. So with culture and urban is a mean for comfort. So you need to give comfort, especially after pandemic. Also, we think of design in distance. So whether from this approach or just understanding the Saudi culture in Jeddah, actually each family used to live in a bâtiment or building. So so each family had its own building. There would be no sharing. We can host guests, but nobody can live in our house because it's a building that is designed for a singular family. Sons, daughters get married, they're still in the same house. So the idea that came up after the Bauhaus and the European building block movement, after Le Corbusier and so on, the idea of apartment housing has spread all over around the world, but it does actually culturally does not fit in the Middle Eastern and Islamic regions, because apartment means that you're sharing the same entrance, you're sharing same stories and so on. And that in particular is somehow conflicting with the cultural understanding of an Arab housing. So if we want to reinterpret the Balad, actually not just only by Roshan's, it's by the lifestyle that had. So it's a singular housing for a person that would be more fitable than living in an apartment housing. Even with all whatever is happening nowadays with the apartments and the selling and the overpopulation that we're living in, but from a cultural point of view, it's due to privacy, and that's what Roshan is about. And also another idea that we can elaborate on is using the illuminated glass to prevent UV as well, which is GV. Okay, and then instead of using a whole bulk of Roshan. And definitely here the slides is just discussing that conservation and adaptive reuse help usually in promoting not just innovation, but a growth in economy and culture and social factors. And this is a quick diagram showing the architectural heritage conservation techniques from a community level until building level. So we have to classify each building. We have to put policies on each building in terms of preservation to enrich its values as well. So quickly, I don't think I have to discuss all the urban interpretation of Al Balad experience, but if we would like to, as I said, remake Jeddah again, it has to go through the understanding of its notion of family, users, community that used to be there, and how to replicate the lifestyle rather than the facade itself. Today, we have found open barahat, which is should be found in adjacent to any cultural facade that we want to build, that is respecting the urban fabric. These are like some studies through the souks and the sikkas around, and covering some quiet plots and understanding that with facades there should be shading system through sikkas. The orientation of the building also plays a role on blocking the sun while you're walking through the streets. These recessed elements also play a vital role where we can be inspired from. And this is almost an imitation, but not an up to accurate look and feel from the heritage facades that we find in Al Balad, but morely we're looking into the round arches with the coral stone effect, which can give us an identity of a cultural facade of Jeddah. Definitely, last thing, hopefully, it's the sustainable materiality in facade through modern design, and that is exactly inspired from the environment of Jeddah with the coral stone, the pebbles, the shells, the clean concrete lines with the sense of water. And this is where we want to make people feel that it is Jeddah, because every city you travel to, I would ask you, what is the most thing you remember? You mostly remember classic houses, maybe palaces, or generally the materials that they're using in their facades. So when you go to Paris, you would remember the whitewashed houses with the black balconies. Or when you go to the UK, you would remember the orange bricks. So when you come to Jeddah, what comes in your mind? It should be the stone finish with the round arches, and maybe the wooden doors, not necessarily to be windows. This is another reflection on how cultural facade has to link with the material and the surrounding, which is the court yards or barahat or mini plazas. Here's a study of the interior through the Masjid al-Shafi'i, and this is an inspiration from the Bizana Culture Center. And as I was saying, cultural looks into all design elements such as forms within functions, and that is pattern, lines, colors, and forms and texture, takes us all again to materiality. And this is like a quick study of what is exactly we find in the architectural facade of Al-Balad. We have a base and a middle and a top. So the top is the Al-Arus, and the middle is where we find the Roshans and the most significant segment in a building. The base is the most crucial and critical part, where it's always active, and due to retail shops and entries, one for men and one for women that time. So today it can't be a family door, guest door, whatever, but base is the most crucial part of the housing, as it is also open to the pedestrianized experience. So we have to look into projecting elements, such that time is the Roshan, but we have to look into how we can bring a shading system technique between buildings to bring this shade to pedestrianized areas. Yet the privacy that women used to take sitting on nearby the Roshan can be also this glass technique that we have also been talking about. So this is again talking about elements. What did we find in terms of forms, and how can we transform that into a cultural facade, where we see arches, balconies, great entrance that is open to the public realm. So this is usually what is segmented from the base, top, and middle. As we said, we spoke about the materials. We have local stone, but we have exported wooden materials. So maybe the idea of exporting that would be still applicable to export other materials such as the glass if it's not manufactured here. But would we bring in all this amount of wood? It is very much debatable, as it can be costly as well. But it can be done here in this sort of building. It's been done as an influence or just a glimpse on the building to show the ribbon of Mashrabiya, which is like a slender wooden panels that can cover the glass. From all of that, we came to put as guidelines for the architectural facade of Jeddah to sort of work with municipalities on how to achieve this strategy and to rebuild Jeddah's identity. Because in the past 50 years, all these building blocks boomed without any sort of regulations on how the facade should be and how the surrounding with the public realm is really having a connection towards one another. Another thing is to learn when we go to Al-Balad, we see some buildings coming in with voids in between, so we can fill also these voids, and what we call is adaptive reuse. We can put in a gate in between, we can introduce new to old. So again, cultural interpretation is very interesting because it's a connection between old and new, and it also can be carried through the innovation of technology, and that's what really makes it interesting. This is also another definition on how buildings today can be for a singular person, individual or families, representing also al-balad look and feel, the facade also image, on how to bring coral stones with a sort of ornament element. It's not just giving you the privacy that you had, but also it brings luxury as well. So architectural design, definitely regeneration plays a vital role in public realm and private realm variations, and it can develop and improve the social level of a community. It boosts the economy through tourism and create phenomenal spaces to users and visitors. These are quite older precedents that sort of reintroduced Mashrabiya in a different material. This is when you play with materiality. This is again the wooden louvers of Mashrabiya, but through the whole facades of the building. This is also giving us a strong image of what the architect is trying to deliver, and how the Islamic geometry also play a vital role in cultural facades due to people. It's not just about trying to state a symbol. It's not about symbolism, but it's more of a passion, love towards Islam, and how geometry actually was part of that expression. So this is what we used to see in our historical facades. And today, with the play of design principle, whether it's harmony or rhythm or unity within variety, you can scale up these geometries and still introduce them in your facades. Definitely, all of this has gone through research with understanding our site. We look into benchmarks. We speak a lot with stakeholders. And we know that generally the process starts with initiation and analysis of the project, and then we bring up options of these facades. We try to do some experiment on how to implement that through new and innovative materials. And as I said, these valuable cultural facades have great values in environment, social, economic, and culture. These are the stages that we go through in design. And these are like recent precedents that we have looked into also on how we can represent wooden, maybe be like a wooden material or a roshan and a geometric ceiling, and keeping it in a more Islamic minimal philosophy facade. This is a last example, I think, when giving the effect of stone material into facades. This is, I think, the museum in Miami, and it's tried to give a connection bond between the Latin society with the American society, and that was designed back in the early 20th century, inspired by the coral shells of the coastal city. And last thing, these are famous conserved sites in representing cultural facades. The newest museum I spoke at the beginning about, it's in Berlin by David Chipperfield, and the rest are mostly representation of connection between old and new together. Such as the Ritz-Carlton also in Berlin, and the Port House, definitely Maria in Al-Ula, and the Crystal House, Hermès in Amsterdam. we definitely have restoration restrictions, and due to structural conditions, material sources availability, and adapting with codes. For Jeddah now, we're still making the code with the new projects coming. So today is a very good opportunity to work on the general identity of the city. So in conclusion, the integration of architectural heritage into modern construction projects adds significant blend and charm, and it's a representation of us, where we want to still develop, yet we are preserving our roots, and it's a deep conversation between past and future. Thank you.
شكرا مهندس علاء. Thank you so much. Our next speaker is Head of Facade Division at Leader Fort Arabia. Specialized in ventilated facade system with 17 years of experience. Let's welcome Mr. Abdelrahman Zayed. We'll talk about terracotta tiles, bridging Saudi Arabia's culture, past, and architecture future. Okay.
Good afternoon, everyone. It's a privilege being here today, representing my company, Leaders Fort, in Zak World of Façades, a company that has been over the past 7 years partnering with Modding, a global leading terracotta facade manufacturer from Germany, where together we have embarked a successful journey in some iconic projects through UAE and recently in Case A, since we expanded our operation in 2022. And as a facade enthusiastic, I'm truly excited by the kingdom vision and the heritage of modernizing its building facade while being rooted to its rich culture and architectural heritage. Truly pushing the boundaries here in the kingdom while preserving their own identity. And between this link of being innovative and innovation and the preservation of the facade, we found it really strongly aligns with our terracotta facade offering. A product that has been really appreciated through the Salmani guidelines and the Najdi architecture. And before we jump into the our topics today, allow me to show you some slides on how the terracotta really shine in a real-world application, because we really get this a lot. What's the terracotta? The difference between the bricks and the extruded facade. So in this project here in Bremen, we see the original facade. It's a brick, normal brick, all facade, where it has been integrated and renovated by an extruded terracotta, which shows the integration between the old and the new architectural approaches. The Museum of Bavarian History, you see how the tile enriched the interplay between the light and shadows on the facade using the terracotta. How the concave and the convex angles has been treated to ensure a flawless architectural facade. Bricks in modern buildings and residential buildings. Sheikh Khalifa Dialysis Center is one of the great examples in Abu Dhabi about the integration between the modern architecture using glazing and aluminium shade breakers, while also integrating terracotta slats with horizontal sun breakers from the stone. How the conjunction details are addressed, the preciseness, the flawless integration detail, how it's been treated on the facade using the terracotta. Sabah Al Salem University in Kuwait. So the main topics that I need to discuss with you today is more about the terracotta itself as a material composition, the production process, the development of the tile itself, as well as the product solution that we are offering from molding. The second point will be the Salmani guidelines, the compliance with the Salmani guidelines. And the last point would be the mud bricks, the innovative solution now for the mud bricks as the first choice in some of the major development here in Saudi Arabia to preserve their own heritage and identity while using a material that suits their facade. The word terracotta is an Italian word. It comes from, it means, the terra means earth or soil, cotta means baked. So it's the process of firing a natural clay. The main composition is water, clay, calcium, magnesium, as well as the main item, which is the iron oxide. The iron oxide gives the terracotta its reddish color, the known terracotta tile with the red color. In case you need to change the tile, it's more additive, the composition, it changes, so you can achieve different color of terracotta tiles. Our production plant is 100% from Germany, where the local deposits surrounding the factory here. Sorry. This is our local deposits where we get the clay and process it through the factory. Under the same roof, we have molding as a terracotta facade, as well as airless for the roofing terracotta, and Gima for the bricks, but today we will be focusing only on the facade solution, the terracotta facade solution. The production stages passes through 6 main stages. The first one is the mining, where we mine the clay and the loam from the ground. The second stage is where we process the grinding, where we make the porridge itself. The porridge will go into a roller. The roller has the extrusion die when it passes through, similarly to the aluminum extrusion, but with clay. Then it goes to the drying chambers. In the drying chambers, the material uses the extra moisture and water preserved in the tile itself. Then the burning goes into a kiln or a furnace with 1,200 degrees Celsius. Then you got the material fired, the extrusion is done, where it gets its compressive strength, and then the calibration finally, where you cut the panel to size. During the drying, the material, and after the burning, of course, the material gets less than 5% water absorption. How the die is developed. The tile starts with an idea, a sketch, a hand sketch from a client, from an architect. This is the static look that I need on my building. So start with a sketch. We take it and develop the die drawings, the technical drawing based on the capacity and the structural integrity of the tile itself. We give it to the client. He approves it with the color sample from the lab. And finally, he gets his tile ready as a sample, ready to be entrenched on the facade. The terracotta, with its versatility, really comes in limitless colors. However, from the standard color itself, we have 18 standard color. Varies from soft tiles, rough, crackled, vulcanized, many finishes, and limitless finishes from the glazing as a glazing solution. These are different types and shapes that we can achieve, and with a massive library of existing dies throughout thousands of projects across the globe. In molding, we have four main products. The alpha tone, the longatone, the baguettes, and the ceratone. The alpha tone and the longatone is the main terracotta rain screen facade cladding. The baguettes are the louver or sun breaker sun screens, and the ceratone is a newly developed system which represent the flawless brick grid system on the wall. So I'm going to start with the alpha tone, which is the commercial tile that we have, the best solution for any commercial project. The tile is 30 mm or 3 centimeters in thickness. It comes in a height of 40 centimeter, starts from 14 centi up to 40 centimeter into a length of 1.5 meter. And this is the minimum thickness that we offer, as you can see here in the photo illustrated below. In terracotta, it's not only about the tile itself. Many manufacturers across the globe can produce a tile. I'm not saying with the same quality, but the terracotta remains as a terracotta. But the subframe plays a big key role in the installation and the overall performance of your building. And this is what we have been trying to emphasize to all the facade consultants about the subframe. The usage of the terracotta with a wrong subframe will lead to breakage and overall ugly look to your building. However, with the right choice of a subframe, you will ensure all your cross joints are aligned. The system will be lifetime integrated in your facade with similarly as installed in the beginning. With molding, we have two patent systems. I'm going to start with the first system, which is the Gen 6. The Gen 6 rapid system, and from its given name, the systems here are completely tool-free. The rapid system, which is the Gen 6 here, you have an integration or an introduction of a horizontal profile. The horizontal profile will allow you to have a longer span of 1.5 meter, where you can fix your carrier, your clips, and then fix your tile directly. So it reduces the amount of embedments and anchorage to your slab. In case you have a PT slab, lots of tendons, we face this in the construction a lot. I need to reduce the connection to the slab. The Gen 6 is the best solution. And secondly, it's recommended for the horizontal installation for the tile where you have a tile in a horizontal format with a long span. The second system is the L2, recommended when you have the tile vertically as well as horizontally, and with the normal bracket T-profile clips with a guided rail. Another thing that in our offering is the joint profile. And the joint profile is a very essential part of this system because it prevents the tile from rattling and from the lateral movement as well as the lateral moving. So you will ensure always that you have cross joint aligned for a longer period. Here it illustrates that you can, with this system, you can start by installing the full system because every tile is treated and fixed individually through a clipping and engagement system. So whenever you have any project, you can just start with fixing your system, and then whenever you receive the tile, it has no prescribed assembly sequence. So you don't have to fix the tile with the sequence. Your frame is already there. You want to fix the tile from top to bottom, from middle to bottom, bottom to top, whatever you like, it can be achieved. Each system is fixed individually. And all you need, let's say the Gen 6, is just a screwdriver after you fix your system, a screwdriver to connect the clip, and then fix the tile. All our clips and system are completely a metal solution. We don't have any gasket which is not appreciated into the facade because gaskets usually shrink when it's fixed in either hot or cold weather. Then it will create a gap between the tile and the gasket. The tile will rattle and eventually it will lead to breakage. But with our spring clip here, directly attached at the back of the tile, it ensures that the tile will not rattle or move when it's fixed to the dead load carrier. This is an example of how the alpha tone tile look on the facade with a vertical installation. Horizontal installation, this is the die on your facade. And by the way, whenever you have a 3 centimeter thickness, that doesn't mean that the tile has to be flat. No, you can have groove in it for a depth of 15 millimeters. That can give you this fantastic look. Different shades of glaze in this project. We have 3 different green shades. H7 Hotel in Germany. This is the die that you can see here on this project. A vertical installation as well. Al-Rahmaniyya Mall in Sharjah, integration also between the grooved, flat, with three different colors and shades. Here you can see on the facade, they utilized flat tile, no grooves, one was single groove, one was double groove, all with the same tile with a thickness of only 30 mm. The Longatone, which is the second solution, from its name, the Longatone is the longer tile that we have. It can come in 1 meter in height, 3 meter in length, and the thickness starts from 4 centimeters up to 14 centimeter in height. The same installation system also applies for the Alpha Tone system. This shows how the tile in 3 meter length, the glazing, which is the ceramic glazing, which is an innovative approach to the kingdom here, rather than having the old bricks with the natural finish. Now you can upgrade it to a ceramic finish, which gives more durability to the tile. Here in this project also you see the tile is fixed with a full 1 meter into 3 meter in width. In this subway station, you can see the tile has 2 different glazing color. In this project in Copenhagen, 4 shades of gray, the ceramic coating itself can come in matte and gloss, as you can see in this facade. The baguettes, which is the sun screens, the louvers, is another good approach for reducing or controlling the daylight, which is another sustainable approach to reduce the energy consumption inside the building. It comes in many shapes, rectangular, squared, or as a fin, as a shading elements. Many approaches that we can offer a full engineering services, whether you fix horizontally or in this job, it comes with a rotatable sunshades. Vertical installation, vertical format. This is how it looks on the facade with a backhole fixation. It's a library where the baguettes are used to imitate a bookshelf. The Ceraton, which is the 4th system, which is the brick grid, it's a floating bricks on an invisible build. A system that's completely designed by us and patented as well, where the tiles are fixed on an invisible stainless steel build. You fix the wires to the required design torque and tension. Then you add the tile, clamp it through a ball structure, completely concealed. You can cap the tile or keep it open, nothing will be seen, and this is the final look that you will have on your facade. It can come in 30 centimeter in height until 1.5 and 1.5 meter in width. This is one example of the Pixel project, that the first project with the Ceraton system on the facade has been in Abu Dhabi, designed by MVRDV. The Salmani architecture called for the terracotta as a solution to link between the heritage and to preserve the nature of the kingdom itself. This is a project that we have rendered. We selected a random school and then we applied a slip brick photoshopped to show you how, with a simple approach of using bricks, it can uplift the entire facade of the school. Another ongoing project under development using the terracotta, basically mainly in Riyadh, in Dubai. The mud bricks, it's the last point that we discussed today, is the similar mud bricks that in the Najdi architecture. Also, it was called to be used in the renovation or the new development of projects that preserving the heritage and the identity of Saudi Arabia. It's no longer a handmade. Now it can be extruded and it can have different finish from ceramic to natural look that can enhance your overall building, not necessarily to put it on an old renovated building for a facelifting, but you see here an office building and it suits well. the salt coating bricks, special formats from the bricks itself can be extruded and achieve the same aesthetic appeal of using a normal brick. The permeability, the unity, and the iteration of the tile, which is the basic pillar of the Najdi architectural. You can see this building, you feel like it's in the Middle East. And lastly, the last project is the Prince Sultan University. It's a renovation of the existing university in Riyadh, and the selection was to use the mud bricks on its facade as in compliance with the Salmani guidelines. Thank you very much for listening.
Abdelrahman.
Thank you.
Okay, for the next speaker, please give him a warm applause and special applause because his father is here with us. From BG&E Facades, Mr. Magid Ahmed, lead facade engineer in Middle East. He has a master's degree in engineering management from Sydney and more than 15 years of experience of structural and facade engineer. We'll talk about new scenarios of when facade go wrong and the future of facade in the Middle East. Okay.
Good afternoon, everyone. I'm feeling privileged today that I'm actually talking to you from Jeddah. I spent 5 years of my childhood in this beautiful city. And also I feel excited that I'm in a room with a diverse group of people. We're gonna talk about the thing that we love the most, which is facades. Okay, my presentation today, just to make it brief, I'm gonna talk about 3 main things. I have 6 scenarios of facade issues that we faced in the whole region, okay? Just, it's the lessons learned, and I would like to share these lessons so we all learn from each other. I'll talk briefly about our company, and I'll talk about my thoughts for what facade engineering gonna be, or what the facade's gonna be in the future. So it's all an opinion. Now, before I just delve into this, always remember this chart, what actually facade engineering is and what is it all about. It's a cross path between mechanical, structural, and architecture. Always remember that. And at the same time, we get information from cost consultant, ESD, lighting, material selections, fire engineering, and acoustics. So this is what facade engineering is. Now, why actually is the facade so important? The facade is so important because it delivers a lot of things. We have thermal comfort. We have to keep the heat out in our region. We need to keep the noise out, the wind. We need to stop intruders, and at the same time, we need nice views. We need ventilation. We need privacy as well, and we also need flexibility in the future if we need to change the building use. All this here is happening in just this zone here, which is the facade zone, which is about 150 to 500 mil if you have fins. So it's a very small zone for a very big task. Now, 6 scenarios quickly. I'm gonna just roll through it quickly. Now, the first one was the stone facades failure. Going back in the reasons why we actually use stone, it's obviously luxury, aesthetics, it increases the asset value of your building. Carbon footprint is low, it's a natural material, and also the life expectancy of the material itself. And it's very much related to the architectural heritage of the region. The stone is quarried from quarries, as I'm sure everyone knows here, and it's cut into big blocks and then sewn into slabs, and then it's made out of the sheets to form the facade. My important point here about this, that the stone properties or the stone physical properties from one part of your quarry, okay, could vary significantly to another part of your quarry. So we have different properties in just one quarry. And just remember this point, because I'm going to come to it in the next few slides. Now, stone failure happens from cracking, stone cracking, edge chipping, staining of the stone. We have frost attack, salt crystallization, and acid rain attack as well. Now, this is a building in our region. It's about 30 stories high, as shown on the right here. I don't know, the pointer is not working, but anyway, it's 30 stories. You've got all this white here as limestone, and this is granite. And we've got a call from our client that stone panels about 1 meter high by 600 wide is just falling from level 25. And it literally broke a 1 meter deep canopy at the ground floor. So imagine the force. Now, we did our investigations and we did the whole mapping for the whole 4 elevations, and we found edge chipping, cracking, dislodgement, as you can see some of the stuff here. And we found some flexural or bending failures as cracking in the middle of the stone panels on the building, and edge chipping at the grooves. And the system here is pretty much a rain screen system. So you have your facade or your stone panels outside and a cavity at the back, and your back wall, and it basically, like the issues with stone cracking, edge chipping on the building, and also misalignment of joints, the horizontal and the vertical, which puts a lot of issues in terms of the movement of the stone itself as a system. Another issue that we came across was stone staining. Always be careful from the sealants used in the joints within the stone itself, because it can leach into your stone. And also with some specific stone types like marble, always it's recommended to do petrographic testing and also alkaline water testing to make sure of the avoidance of the presence of pyrites or iron sulfide that can get into your stone and cause these stains. Another project for the stone, it's been held by like an old-fashioned installation methods, just using mortar and metal threads. And these metal threads basically corrode from the moisture in the mortar, and then the stone will be held only by adhesive and will eventually fall. So the lesson taken here with the stone, always discuss with the architect, with the facade consultant, with the owner. Do you really need to install stone up at level 30 of your building? Do you really need that? Are you not going to touch the stone? You're not going to feel the stone? So always have these discussions. Focus on the fixing designs, focus on the joint designs, and also testing. Like in that high-rise building where the stone failed, the designer used technical data sheets for the stone, which is natural material. Although they should use tested data from the stone that will be installed on your building. And hence my comment for the quarry, how it varies from one area to another. And also the factors of safety for the stone, they're very important and unfortunately been missed in this project where the stone was falling down. Now, another scenario that we also came across in the building, which is the failure of awning windows. So this is just a project where the failure of the friction stays after a wind event. Another photos from the same project. There's no limiter or restrictors, and these friction stays, they have got capacity and it failed. And this is a 55-story building high with all awning windows, and unfortunately one of these just flew off in a wind event. It's 2 meters high by 1 meter wide. My advice here is not just a matter of the client goes to the supplier and just asks for awning windows on your building and that's it. No, it's what's the weight of the glass? What's the weight of the window? How is the window fixed to the frame? What the fixings are, so what the grade is. Is the window tested in an open position, in a closed position? So it's a whole process that you need to go with your facade consultant, if any, and the client. We all might be familiar with this. It's not in our region. However, this is basically what happened on the other project, were just windows falling. And the windows, in this wind event, there was a negative pressure in the building itself, which pushes the windows and just flies them off from your building. So always remember, it is not just simple to put your awning windows and put them on your facade or curtain wall. Okay, I'm just aware of time here. I'm gonna go now. The second or the third scenario here, we have water leakage. Again, in our region, it's a common issue. It is important to note that it is not just getting a stick curtain wall or a unitized curtain wall and it says it's tested and let's put it on the building. However, we'll add few features to it. It is not that simple. And this is the case here where we had a building like that, which is stick curtain wall, and the client or the architect added a whole heap of features on the facade and hasn't been tested. So this is what happened on this, and it was a rainy event. Again, this is in our region here, and the water ingress was severe, and the building was still hasn't been handed over. It's still brand new building, and unfortunately, it is just a loss of a big damage, damage to the brand, let alone damage in revenue, and etc., etc. So, and this is like as if it's raining in the building and also outside the building, and all the associated issues that might come with this in terms of the mold growth and stuff like that. So I'll just run through it, and always remember the principle of the water leakage, that for the water to get into your building, you need the water itself, you need the opening, and you need the force. You need these three things. If you can eliminate one of them, you will prevent water from coming into your building. So water we cannot eliminate, it is there. Openings also we cannot eliminate, but the force we can by achieving pressure equalization, for example. So this is just going into the principles here. Now the fourth one, which is the mold growth, just to continue talking with Medhat in the morning, was talking about, this is interstitial condensation. Again, some might have seen this on my YouTube video. This is not just one building, it's six buildings, each one of them about 50 stories high. Simple mistake in the facade has costed a fortune. Air leakage from outside, from the facade, from your fins at every bracket, and it's hot and humid air, and that's what we have plenty of in the region. The air, hot and humid, will hit the surface of your dry lining, reaches the dew point, and it just condensates and mold growth will occur. Again, huge damage in your reputation for the building. And to fix this, it's pretty much a big problem, because it infested not just the rooms, but also the whole MAP system for all the 5 towers. So please do not underestimate your facade, and get the right people to look at this from early on all the way up to handover. So I'm just gonna continue, and this is just some photos from one of the rooms. And this is what happened there. These are all the fins, and they just leak at every bracket at each one of these fins, and we have some photos there shown on the right hand side, and the air just comes in. This is a typical video of the same building, where just the air is coming actually inside, hot and humid, which is not supposed to happen at all, basically beyond your facade air seal. But this is what we encountered. And this is what has been found on one of the buildings. Now, the fourth problem here was facades creaking noises. Like, one of the clients contacted us. They hear a funny, strong noise at certain times of the day in the facade. And it's basically the issue was the facade was confined. There's no room for the facade to expand and contract. It was, again, very easy fix. And these we grabbed photos during construction. And we noticed that all the brackets at the top, it had no vertical slotted holes whatsoever. So it's something very simple, caused now a very big problem. to actually remove all your glass, remove all your internal finishes to fix this issue. And these are just some drawings from the drawings for the building. All the holes are set, so the slabs cannot deflect, the facade or the mullions cannot expand or contract, and it moves. When it tries to move, it produces these squeaking noises. The fifth problem that we faced also, sandwich panels, blistering. That's again in our region, or delamination of the sandwich panels, which is just delamination of the external skin, metal skin from the insulation. Again, incompatibility of the adhesive and the products to our region has caused this problem. And this is just a video from site, and this is not just one warehouse, by the way, it's a whole like 30 or 40 warehouses with the same issue. So just minor problem could cause a big dollar figure in front of it. Now, facades is not just above the ground. The facades also goes under the ground in basements. So leakages in basements is again a big problem. So we've been called by a couple of clients for 2 basements leakages in the region here. Again, remember the correct waterproofing system, your proper testings, and all the consulting bits and pieces right from the early start will prevent such problems. Again, this is another one, leakages occurring at basements and failure of the waterproofing system. And this is just a quick video showing the level 4 basement on the eastern elevation near zone 36. I've got to run this because I'm running out of time. This is a similar similar issue there. So I'll just, so the water ingress from your basement walls. Okay. Now, who we are an Australian company. We've been in business for more than 50 years back in Australia, and we have offices in every state in Australia. We're about 1,200 people, and I look after the facades in the Middle East, based in the region. We have been in the Middle East for about 20 years, and we don't only do facades, we also do structural engineering, civil, infrastructure planning and support. We do materials technology and also construction engineering and bridges engineering. About the facades, we have our offices, Melbourne, Sydney, Auckland, Perth, Abu Dhabi, Brisbane, and London, and we do the whole facade consulting, all the stages as pre-tender and also the post-tender. And the third item that I'll talk about here, which I have 4 thoughts of where the facades is going in the Middle East. First, I believe, or I think that majority of all the projects, if not all the projects in the Middle East, will have a facade consultant on it. And some cities in the region here already adopting that. So obviously the facade consultant scope will vary based on the client, whether an architect, developer, main contractor, or facade contractor. So it will be tailored based on who the client is. I think the progress or the widespread of building integrated photovoltaics will be in the region. We just finished this building in Melbourne, and we used Scala panels as the thin film technology panels, which doesn't really rely on direct sunlights. And it generated, and we worked from the early start with the supplier, with the architect, with the mechanical and electrical engineer, and also with the contractor to actually integrate the panels into the system right from early start. And that's what's highlighted here. They are the Scala panels as the thin film technology, building integrated photovoltaics. And these are just some photos from site where it has been integrated into the building, and they just hooked on, and they are structurally glazed with vertical runners at the back. These are photos from the factory itself for the panels, and it is basically the objective here achieved, which we saved 8.1 tons of CO2 in Melbourne for just one elevation. and it saved 20% of the building energy consumption. It's all from clean energy. And at the same time, we achieved 5.5 star rating based on the local star rating technique, which means you get higher return on investment from a developer point of view. In fact, a company or an organization here in the Middle East adopted this, which is Al-Hamra Real Estate in Kuwait, and they use the same technology on their car park. And the entire car park energy is generated from clean energy using another panels, but it's the same technology as the thin film technology. And by that, they actually avoided 360 tons of carbon dioxide per year and generated 400 megawatt hour electricity annually, which is enough to actually energize or provide energy for 5 homes per annum. Another building, they used monocrystalline technology as again BIPV. That's in Dubai. So I see this technology is coming, but it's just a matter of time. Now, there's a lot of challenges with it though, in terms of the heat, the sand, the dust, but I can see this all will be resolved by different technology, providing enough ventilation behind the panels, maintenance, providing an angle specific for the panels, not to accumulate the dust, etc., etc. My third thought, we are working on a project in Melbourne now, which is a facade tracker. Like we track our facade, i.e. we spend a lot of time in designing the facade, specifying the facade, workshops, materials, spending a lot of money on testing, inspections, documenting, installations. And after the facade is built, no one knows what's going on. Did the facade actually perform? Has it achieved its performance? No one knows if it's tracked or not. So this is just sensors will be embedded into the facade to get the solar radiations, to get the external wind pressure, internal cavity wind pressure. Is there an air leakage in the facade? Is the surface temperature of the glass inside and outside? What's the system temperature? So the facade will talk to us. And that's what I can see could be happening in the next 20 years. And this is one of the sensors that we are currently working on to develop this technology further. And it will be connected to the BMS as a building management system, or can be monitored on your phone or on your tablet just to know how your facade is performing. The fourth and the final tool, which we are also working on, it's called a carbon calculator. I'll just skip this. This is what it looks like. So you select what the facade system is, whether it's curtain wall, window wall, unitized stick, and then you select the geometry of your facade or glazing, and then you put your frame, your filling, your window, and at the bottom here it will tell you how much embodied carbon in your configuration. So you can actually track how much carbon in your facade itself. So this will give us informative decisions in order how to build a more sustainable facade. And this is what we're working on now to basically decrease the, or that's, I'm gonna run through it. Anyway, so it's the whole idea of it is to monitor how much carbon in your facade and just minimize it as much as possible to suit the requirements, say for your green star rating or your LEED rating. Now I had my last slide here, which was the most important thing to remember, which I need to bring it back if possible, which is this here. Please always remember this. Is your facade is as important as your building structure standing up. From the examples that I've shown, clients and developers are struggling to fix the issues. It's maybe sometimes they tell me it's easier for me to destroy your whole facade or dismantle it, fix the issues and put it back. So always remember, it's your facade is as important as your building structure standing up. It's like a concrete beam cracking or a slab failing. Thank you for listening. Thank you, Abraham.
Thank you, Max. Our next speaker from Portugal's Rui Monteiro. Commercial Director at Ephesus, will talk about disrupting the future of building envelope, introducing the triple FR system. Please welcome on stage. Okay, thank you.
Thank you.
Okay.
Thank you. So good afternoon all. I think that Mr. Ahmed just prepared an excellent stage for me. So he spoke about moisture, he spoke about water on the facade, about leakage, and here, as Ephesus, we are here also to help on these particular stages. That is, normally we know, that buildings have issues of water inside, of leakage inside. Nowadays, fire is also a concern. So today, and even being a commercial director, I will not sell anything. I will just try to add something else to the market and try to bring you something different. So Ephesus, it's established in several countries as UK, Dubai, Portugal, Spain. So we are spread among the world. And we also have the market on our expertise. So we go market by market to understand what are the requirements, what are the what are the certifications that we need. So we have more than 20 years of experience and we try to adapt to the necessities of each client. So we are not here to provide something standard. We will customize it according with the needs that you have. So concerning this, we went to the market and we tried to understand a little bit more. And of course here, we know that outside it's super hot temperatures, inside super cold. So we need a lot of energy to bring this air conditioning inside to lower the temperature to be comfortable for us. For what we could understand, 80% or between 70 to 80% of the buildings cannot maintain a comfortable temperature inside. Because what? Or it is too cold, or it is hot, so it's difficult. And if we don't have energy efficiency on our minds when we are designing and building, we know that it will be an extra cost for us, because this means that we will waste more money to bring the temperature down, to waste on energy. So make us think if we should or not think a little bit better when we are planning our structures. So getting on top of this and looking at this image, it's super easy to see where we can reduce immediately the losses. If we focus on windows, floors and connections and doors, we will save 50% of our losses. So I will not pick on this side of the house, just that side is 50%. So let's focus on the biggest part and then we can go small by small. But important to say, if this is not properly sealed, as Mr. Ahmed was saying, we have water inside, we have air inside, we have mold, we have everything that we don't want in our building, in our high-class building. So, if we go and an analysis here, and with all these losses that we probably could have or could improve, we are saying that just in Jeddah, we spend 71% of the energy to cool the rooms, to bring the temperatures lower, to make us, to be a possibility for us being comfortable inside. But there are any way that we can try to reduce these costs on energy by implementing something else on the phase of construction? Maybe yes, maybe no. Let's see if we can help. Also, if we study the demanding on costs, it's increasing. And it seems like we established there from 2016 to 2020, but till 24, it's increasing more. So this means that it's being even more expensive for us to maintain these temperatures, to build to bring our energy efficiency to our buildings. And this is serious because we expend a lot of money building our own building, saying that is the best that we can bring, but at the same point we are bringing a lot of cost to us. But not only the atmospheric agents, we also have fire concerns right now. As you know, and I don't know if you are aware of the Grenfell fire that happened in London, one of the biggest, that now the statement came out and said everyone is blamed. Because they didn't look at this. Because this is something that we say, okay, let's save one riad, 2 riads to place something that is more affordable, but we are saying that the lives of the people that are inside the building are not worthy of 1 or 2 more riads. And I think that we should think here, because it's something that it's a disaster. We don't want to speak about this because it's not good, but we should be aware that every decision that we take, and even on these solutions that we are speaking, that are solutions that we don't see, because we don't see these membranes, these weatherproofing membranes, they are behind the cladding, and most of the times, once that cladding is what is exposed, we have, how can I say, we are more agreeable to say, okay, I will expand more on the cladding because people will see, but behind, okay, I can go lower. But I think that it's something that could bring us some awareness. So saying this, Ephesus have a huge role here. One is weatherproofing. How can we improve these interface connections, but get a better performance in our installation? So how can we do it? Another thing is efficiency. How can we bring more efficiency to our buildings in a way that we can save more? Another one, it's sustainable. So something that, of course, you will invest today, but will take time to be renewed by saying. So it's something sustainable in time, and also that can help you achieving the carbon footprint values that everyone wants for the buildings. So where can we do this? On the opaque areas and in the interface areas. That was exactly the points that we were speaking on a previous presentation. That was around the windows and the concrete part of the building, that most of the times we apply insulation and then direct cladding on top. This means that our insulation, imagine, it's like compared to a supercar. You buy a hypercar, but if you don't have the right tires to perform, it will not perform. If the driver don't have the instruction to how to perform on it, it will not perform. So I could bring the best insulation possible, but if I don't protect it, if I don't take care of how to apply the things, it will not perform. And same thing on the interface details, that we know that interface details are the connections between perhaps metal and concrete. And this means that we will have different movements. Once that we have different movements, we need something that can accommodate that. We will get there. So for the facade part, for the opaque areas, here we have a huge difference between the interior of our houses and the outside. And the interior is way too cold and outside it's way too hot. So normal moisture condensations can appear. And our insulation by itself cannot protect this. So something as a vapor control membrane, something that allows us to avoid condensation, to protect our insulation from water, could be a solution to improve not only the efficiency, but also the durability of our insulation that we are placing on the building. Another thing, it's the details of the interfaces. As you know, for years we used EPDM membranes. So EPDM were elastic, have memory, so we can use because we can stretch it in different directions and doesn't crack. But right now, EPDM, it's not a reliable solution because of fire. It's 100% combustible. So we thought, okay, so we need something that it's not combustible, but also can perform in different directions. So, and this is the PDM along the years that we started with the standard rolls, then we placed self-adhesive bands, then the gaskets, so we customize according to the needs. But now, with fire, we really need something that does not burn, or at least don't contribute to the spread of the fire. So for the opaque area, we already spoke of a VCL membrane, A1, so doesn't burn. And now, Ephesus came with something really, really interesting that I challenge you to pass by our stand and to check and look at the solution. There is something elastic, so it behaves like an EPDM, and waterproof and fire resistant. So it's something unique. It's something that combines the three of all, so it's the best of the world that we, by saying that combines everything that we need. And it's something that will help us don't have that water inside, that will help us to avoid moisture to get in, to create the mold and everything. And it's also something that can be stretched in different directions. So, as a system, we can provide right now the full system. So a vapor control membrane fire rated, A1, top class, and a interface membrane, also fire rated, top class to prevent your building. So improving here, what we are saying is, okay, we will decrease the level of fire, or we will at least take less risk of fire. We will improve regarding the water inside, so water will be stopped by the membranes, and also condensations to appear in the interior. Also, we don't have only for the facades, but for the roofs and everything, so, but today we will only speak about the facades. So, again, we cannot be on the market without being approved for the market. So we study the market, we tested the solutions, we have the certification, we know that green certifications are now being demanded, so green certifications we already have. ASTM, that I understand for the Saudi market, it's the regulations that it's most considerable here on the market. It's the American standards. Also, we have the most demanding standards that are the European ones. So even if the client has the necessity of understanding if we could have some certificate, we can aim for and we can look for. Because what? We are worldwide. So we are not only here, as I said, we are a worldwide company with several big and important iconic projects, as the Museum of the Future, Canberra Airport, headquarters of Apple. So we have a lot of projects. But okay, this is worldwide. But in here, also in here, we are also present here in most recent projects and some from the past, and iconic projects. Projects that we know that someone thinks, okay, let's prepare the facade, let's understand the details, let's bring this awareness of moisture, of fire risks, and let's protect them. Red Sea, Danam, Riyadh, so several projects also. So, as a conclusion, Ephesus, it's not only a provider. So, I spoke about some things that we can offer, but we also have the consultant part. So, and this is free, by the way. So, if you have a project, you can come to us, say, I have the project, I have these details, let's look at them. We will look, we will project the solutions, not our solutions, the solutions that maybe could fit there. We will study with you. We will be since the beginning till the end. So after providing a material, we will provide installation, guidance during the installation, we will do the site reports. So it's a full package. So the products already are in the standards. The commercial service, it's one of the differentiations that we have. And then we also have on top of this the technical service that we can provide. One of the amazing parts is that we are not a standard ones. We customize according with the needs. So if your project has specific needs, we will develop according the needs of your project. So this means that for any particular shape or detail that you are not so aware, you can come to us. We can clarify, we can understand, and if we can help, we will help. If we cannot, we will not help. Because we only want to do what we can and not what we desire to do. Here, just a quick resume of what I said. Imagine for your building, normally the cost of these weatherproofing solutions is 1% of the, and 1% we are being too much aggressive because it's 0.0001%. The cost of the weatherproofing solutions against the total cost of the job site. But the problems that you can have of doing poorly, it's 30% of the cost. So sometimes we are not aware, but thinking on this on an early stage, on the design phase before the installation, could bring us some savings in the future. This being said, we are available. You can pass by our stand if you want to know more about this, of what we can offer, and even from the knowledge of the solutions that we can provide and how can we customize. And for today is this. Thank you very much, and see you later.
Thank you so much. Okay, the next presentation will be special because it comes from a designer. Our next speaker, Mr. Michel Mossessian, CEO and founder and design principal of Mossessian Architecture. He has designed landmark buildings globally in UK, China, Qatar, and Morocco, and France, including the main square and 26 buildings in Misharib, Qatar. The presentation titled From Concept to Craft. Please welcome on stage.
Well, thank you. Good afternoon, I think. Thank you, Zak, to invite me again. I've done that once, so if I'm back, is perhaps I did something right. I've heard diversity of presentation, and I'll take an African phrase to say, it takes a village to raise a child. That would be the motto today. It's going to be about cities. You'll see how I unroll my line of thought. By 2050, between 2050, when we're carbon zero, and the end of the century, will be 10 billion people. There are other solutions emerging. The world we're in today will probably be different then. We designed Google DeepMind headquarters in London, and I came across to know the founder. And Demis Hassabis, one day in a conference, talked about the role of the nurse versus the doctor. The doctor, like architects, like engineers, are completely submerged by technical data. With the input of artificial intelligence, DeepMind believes they're going to save more lives. We have the nurse, we have the doctor. Next, the doctor may be replaced by the system, the machine, the AI. There'll still be super doctors, but the nurse will be the most essential person that you get in touch with. So, cities, I'm gonna show you. It's made of facade. It's all right. The facade is kind of the membrane between the inner world and the outer world, between the theme of my architecture, space and people. These are representation of power from different era of the European legacy. What I'm going to say is not to apply, but it's a reference to know where we're coming from and how we can perhaps learn from heritage, past, legacy. You have the first facade in Paris, state. Second, kingdoms. Third, religion. And in the 18th century, a visionary architect, century of light, said, I'm tired of doing facade as an architect. He was the architect of the king, by the way. I'm going to bring the city inside the building. I'm going to bring the engineers to work for me. Because really, when you do the facade and you do the engineering behind, you miss a lot of the story of what is the purpose of what we do and for who we're doing it. So this is a visionary image of a universal library. And if I go back, you see those drawings? There's no people. Oops, sorry. First time in a representation of architecture that you have people in a space. So space and people are essential. And what we borrowed from that visionary system we allowed mobility to make spaces of stress, right? Airport, shopping mall, train station, you always have somebody in your way. It's stressful. How can you revert that? Is to look at how the most precious shared spaces we all belong or will have to move to make a sustainable planet, cities. So I'm going to talk about what I know, because I was born in Paris, I moved to New York in my early 20s, and I've been for the last 23 years in London. And I'm going to tell you how those cities were shaped with systems, laws, and interest. Sometimes very selfish, but most was to the benefit of the collective. What we have in the common ground is the ground. All the cities have a continuous public realm and parks. So, you know this quotation by Winston Churchill saying that buildings are shaping our behavior. What about cities? I think the cities are not shaped by engineers and architects. We just respond to who establishes the laws and the interest. And it's concept to craft. So what starts is the concept, why the city is made and how it just happened. I'm going to go through this and then go back to that. These are the type of profiles of people I've been working in the last 40 years of my career. They're all different personalities, they're all very influent, and those profiles may change in the future. It's always evolving. We have to know who is commissioning the spaces we end up living in. So, in the context of a city, you're going to see some of those figures to influence my purpose today. I'm going to start with London, going backwards in my life, because London is an attractive city. It's a mixed-use city. Any place in London you work, live, and play. Any neighborhood. There's no center. And there's a continuous public round. So I'm going to call it Line, and you're going to see why. This is London before the Great Fire, 1666. It was a middle-aged town, European, made of little streets and buildings. And when the Great Fire happened, the king commissioned Christopher Wren, the architect of St. Paul, the architect of the king, to draw a plan to rebuild the city. What happened to that? This vision was never realized, and when you see a rendering from a friend of mine that illustrated what London would be if the Christopher Wren plan had been built, it'll be Paris. We are in the 17th century. So instead of that, the collective of owners, which were the lawmakers, the merchant, the economy of London, said to the king, we don't want your vision, we want exactly what we had. So they really instrumented to rebuild exactly what London was made out of, with a few exceptions, and a legal system, which we call party wall, which made the city completely transformed and allowed it to survive and be what it is in the 21st century. The party wall agreement is just a virtual line that divides two property. One owner, another owner. I can do anything I want on my land, on my property, on my block, and as long as I respect yours. And there's this line that divides, but allows you to rebuild according to time, economy, needs. And that line is pretty typical in historical London, but when you go to the city, it's there I mean, those big towers that came emerged from three-story buildings. So London was rebuilt exactly from the original plan with this notion of a void line that allows you to build as you need. This is a picture that in 2012 from the Tate. There were literally about 60 cranes at all times in the city of London. So that revival allowed to let emerge high density zoning into the center of the commercial city. Okay. Now I'm going to shift to Harry. This is a famous developer from New York. And here the pole is really economy. It's New York. It's based also on the start of a European pattern, city fabric, which was New Amsterdam. And something happened at some point which was very virtual, was to project a grid, abstract. There was no need, there was just a vision to extend city blocks all the way over the rock of the island of Manhattan. That was a projection. It's like inventing nothing. I mean, like inventing zero, right? It's an abstraction. But that says a lot of things that you can do with other numbers. So here the projection, the virtual projection of a grid, which was the ground, allowed the individual owners of each block to build as much as they could. And as much as they could with a certain set of rules. And this rule was the air rights, which is the only planning rule you have in New York. So you can build as much as you want next to somebody, but you may have to buy his air above his lot. And that frees the relationship of height. So I can say, I'm a small building, 10-story high, tall, and next door, the owner wants to build 150 stories. He has to buy my air above me. He can go 10 or 20 stories, and if he does that with the surrounding owners, you can go up. But that works very well because the division of the lots is very dense also, like similar to London. And the freedom of building up is given by these agreements that people make constantly with each other. So that defines a community of interest on one simple law, air rights. And where New York is so successful, because there's a lot of new New Yorks or new skylines emerging around the planet. Why this one remains fundamental, like London, it has a ground. The grid is continuous. It is for people. So that explains the principle, and that's the new explosions, and now the finger towers are defying even gravity. I don't know how much further we can go. Now I'm going to go to the city I grew up with, in Latin Quarter. And I'm showing, do you know, anybody knows who it is? This is Coco Chanel. Do you know the brand Chanel? She was, it's funny that Paris is, I'm going to explain, kind of a straitjacket city. It's a very regimented, it's not romantic, it's very military. What happened in Paris was the act of a statement, post-Napoleon. But what's funny here is like a city that is so structured with boulevard avenues creates and provides the most rebellious individuals you can think in a Western culture. Coco was one of them. So Paris was also like London, like New Amsterdam, New York, a middle-aged city made of density. And at some point, something happened. Was not a fire, was not an abstraction grid, was the need to make arteries. And why? Was just the fear of the invasion potential from East, which is Germany, the brother country. So they needed to be able to move the cavalry from east to west very quickly. Horses, right? Armaments. And that became the romantic image of Paris we know today. But there was a radical cut. That allowed the city to survive the 20th century very well, because under those big cuts they could build subways. And it was very efficient, much easier than London. But it froze itself into the shape of what it protected in a way. So there's not this dynamic structure that London has to rebuild anything you want, as long as you can negotiate your party wall agreement with your neighbor. So Paris, unfortunately, will remain forever a 19th century city, where London is a 21st century city. I'm sorry to hurt my origins, but London has found a way to negotiate, to interact, and to engage with the needs and the economy of the time, right? So some images that are very known, but it's all very the straitjacket. And this is Paris as it is today, with all these breathing arteries, which was very convenient at the time, but more problematic today. And actually, the trend of the city is to make a very pedestrian-friendly city continues throughout, with cycling on those arteries instead of cars. All right, this could have happened. It could have been a disaster. That's the Corbusier plan, to say erase Paris, rebuild projects. It could have happened on twofold, because Germany, the generals during the Second World War were ordered to destroy Paris, and lucky the general in position loves Paris so much that he didn't do that, so we won't have to do this. Anyway, it would have been probably different. Adventurer. I want to talk about the city I lived most in my life, since my teens, without having an address. It's Venice. And why is it important? Because it's the same model as London, in my opinion, and New York. It's obviously it was linked to the Silk Route, to the Spice Route, to all those routes were making the trade between East and West, animated by merchants. Venice is the only city I know where there's not one building that doesn't touch another. All of them, even the churches. They're all adjacent. So the way it was built was pure negotiation of my need along the little streets, and when you need to relax a bit, you make a campo. And then if you want to relax more, you make a big piazza. And it was a continuous construction, human construction, a negotiation of the collective and the community. So Space and People there is a beautiful transcript of what it is today. Unfortunately, it's just not just tourism, but it was for people sailing and trading with the world. There's only one building that doesn't have a neighbor. It's a tax collector. No? Is it funny, no? Anyway, that's the only one I found. Now let me talk to you, because I just give you a transcript of where I'm coming from, which is the different cultures on the Western Hemisphere, and what I've been involved with. And the approach and the attitude I have is not to come and, hey, I know how to do it. You know, I've learned that in Chicago with SOM, and I can do any high-rise, and I can. I'm going to give you the best technology you can get. No, I have a different approach, which is really how to set the dialogue to the needs. And this project was all about people already, was set. The tonality by the client, Shekamosa, was how can we build today what will be tomorrow considered as our legacy. Because, you know, not like Saudi Arabia, Qatar has very little culture, very little heritage. There's the fishermen villages, and that's what we took as an example. And you know what? How come those poor people fishermen could make a very sustainable environment and raise their family and work and enjoy being protected by the construction of the massive construction of their little hubs and villages. And that's what we took as a reference to work with nature. So what we've been involved, I mean, I say that because a few people have been working, okay, it takes a village to raise a child. But we were probably the kid around on the block when we started and won the main square. But we ended up doing 26 buildings. And I tell you, the tonality was really given by our approach, which was, how do you feel when you see, well, our design, but when you live in the built environment we created? And the question was always, is that Qatari or not? And we passed every presentation to the public because they were very keen to engage the community. And for some reason, it did respond to their calls. So that's why we ended up doing a lot of buildings. One of my fascination was the understanding of calligraphy that you all probably master in this room. But the incredible nuance, it's not about a metric, a grid. You know, everything is a grid. We've seen a lot of grids today. Exterior wall is a grid 1.5, and you know, you just develop and roll quantity of buildings, and the world could be organized according to a grid. But here, no, it's a modulation. The beauty of the Arabic calligraphy is like with the same ondulation and a different accent, you have a different meaning. So I thought it was like, wow, this is really breathing people. This breathing a notion that there's nothing systematic here. So my language that we developed for Mushrab was, we're going to do a modulation, and the accent is telling you who lives there. Okay, the Mushrabia, and all these incredible sophisticated relationship between outside and indoors and outdoors. So it became the motto. The second one was because we won the main square, and it was designed by people sitting in London, the master plan. And they say, hey, this is a dream project, let's do an Italian square, the size of Piazza San Marco or Piazza Navona, okay? Only difference is like most of the year, you can't be there. It's too hot, too humid. So even though I designed a place which was not to be busy with sculptures or monuments, or was just a jewel box to protect and give what you have most precious. And I said to our client, your people. And I tried to design a place which was unifying in the sense of shared values, which is to belong in a place, but also to be welcome when you're a visitor. So that became a very strong relationship of mass and void. And I took, sorry for the bad quality of the picture, but somebody can give me a better one, I'll take it. The Majlis is one of the greatest illustrations from the Arabic culture of meeting around a void and exchanging and talking. So I wanted to do an urban Majlis, except the problem is the heat. And so we worked with our engineers how to allow to be in the square more than just 6 months of the year. So we went to a total environmental solution using the sun to produce energy to cool the space and filter with a lot of technology there, which is, okay, the benefit of our incredible technicalities that we can provide. So the challenge was good to go from 40 degrees, about 40 degrees, okay, to below 30 degrees in a per meter, like a majlis. Okay, imagine this is a bench sitting, and then you can be there during the harsh weather of the year. Okay, so we did that so that the vision became the thing, the square. You know, I know it's been very used from different world events that happened in Qatar. And there's amazing, I can give another lecture on this, just these little passages, and now with a reminiscence of historical legacy. Yeah, so I go to something that is closer to you, and unfortunately I do a lot of projects that are in Saudi Arabia that I cannot talk about. But there's one that we did, so because I didn't win the project, it's okay, I can talk about it. They allowed me to. It's in Alula, which is the cradle of civilization, Nabatean, 10,000 years. This is the learnings for the next century for us to all know how you can live in a sustainable environment without over-consuming energy, really. So the project I've done is a style exercise, okay? I do a lot of different things from what I've just said before. It's like, how can you be, the power of nature is so strong that you cannot add anything that could perturb, distract from the beauty of the settings, which is rock and oasis. So how can you be there without changing there? So that was like kind of a play that I've engaged with to say, what if you conceptualize, which is the art of abstraction, which is very Arabic, Islamic actually, not to show nature, but to represent, to abstract nature, like geometry, algebra. So it's also dealing with the void and the representation without being what it is, right? So I say, what if I pixelize my view and slowly do a transformation to let emerge a building that will kind of mingle and fade away into the scenery? Okay, it's an abstraction, right? But so these are identified the different tonality and layers between the green, the rock, and the shadows, and came with something. First, that was the concept. Then there was a sketch. Then we developed that. What are those pixels made out of? Obviously, nature. There's like an abundance of native species, even in the desert, that is fabulous to learn from. And to maintain, and there's the natural elements, which are the rocks. So try to engage with a natural means of construction. All right. And we drew from the palette of Alula, which is all the pigments, and start to recompose really from the abstract to the reality of the program, which is a cultural center with a culinary school, and the students in residence. So, and then, you know, massive construction, like we knew how to do that in the past, and it's coming back. You know, get to it. And reflecting to this concept, again, sculpting the void, that I love this diagram, which is from a scholar from Saudi Arabia, where the inside is out, the circle. The outside is inside, totally protected. So it's really, I love that concept. So I'm not ready yet to be doing a city analysis like I did for Paris or New York, but there's something very strong there that I believe is linked to the majlis, is linked to the void, it's linked to the sense of shared spaces and community. Right. So this is kind of how we organize always our most precious things, is to value what it is that people, is that an object, but the relationship to the void and the mass is essential, especially under the sun. So that's what it became. Okay, so I'm not gonna, I want to go, I think I may have something else, one more thing. Yeah, let's go back conceptual. I started with artificial intelligence, and actually they didn't invent, AI will never invent anything for us that we haven't done before. If we take the first book, the Bible, which is shared by two religions from Abraham, it's the first fiction, right? It's the most beautiful, the most read book that you can find, whether it's a Quran or the Bible. And all is fiction, all is storytelling. So let me end up with one, because I've heard a lot of talks about how to make sharp, crisp buildings. I worked at SOM Chicago. I was with the people who built the Sears Tower and the Hancock. They were my professors. But that was the Bauhaus. Beautiful, very Germanic then. And I enjoyed that. Then after that, I was lucky to work with Frank Gehry when he was about to emerge. And he changed completely the form to allow fiction. This is the first time you had storytelling about the fish being prehistoric, before man, right? This is the idea of Frank. If you have to be going to the past to take example, well, I'd be fish before humans appeared. So that's a funny thing. And then my work in the last 20 years, but now it's going to evolve. So space allows fiction. I say, space is what we have most in common, to be shared, to be valued, to engage each other. And that's what I believe we need to do. Now, all those are thoughts for us to think, maybe for me at least to keep going. But it is the village again, the global village, village monde. It's from the French. It sounds pretty good too. It's about what we have to protect most. How do we create a space where you include, and you make people welcome, and you feel like you belong, so you can be open and generous to others. Well, I believe villages, which is pretty much how Europe started, but I'm not taking that as a model. I'm taking that as the fact that perhaps in 50 years there'll be no cars in our streets, so why do we sprawl our cities with the need of mobility? I start to know pretty well the different cities in Saudi Arabia, but Riyadh is like Detroit. It's a car city. Jeddah is better already because there's a whole town, there's heritage, there's a relationship to the Corniche and the water. So there's an obvious, and thanks to the lecture this morning from Ms. Addas, but it's true that it's part of the value and making that the destination for the future. So 10 billion, how are we going to deal with that, but at the scale of a global village? That's a type of thing that we think we should all concentrate. And yes, the circular economy, cradle to cradle, and maybe stop thinking too technical, because in innovation, I go around the world. I was in Japan not long ago, and I see Japan is very advanced on technology, as you know. And in the building industry, the greatest inventions are about tsunami, how to resist a tsunami, hurricane, or catastrophe. What creates it? So they are inventing to react to nature. Why don't we start to work with nature and make sure that there's no tsunami or catastrophe that we have created by our abuse of energy consumption. So all you guys, I've seen lectures, technical, and exterior wall is my expertise, okay? So I can craft, I can give a whole lecture on every single buildings I've done. But why are we spending so much time to go against heat, against the sandstorm, whatever? But why don't we live or learn again from what nature does and gives you, and how they did before we had electricity and cars. You're happy people. So be a kid and dream. Thank you.
Thank you. Done. Thank you, Michel. Finally, the lunch time. There's a break for about an hour or 30 minutes, because we are late a little bit. So please welcome in the next hall. We will come back, I think, to 2:50 sharp. Thank you. Please have your seats. I hope you enjoyed the lunch break and have some connections. Let's start our third and last session for today. Our next speaker, Loïs Delhom, Mr. Loïs Delhom, General Manager from at Telecom Acoustics. We'll talk about facade acoustic 101, tackling noise challenges the right way. Please welcome on stage. Great.
Hello everyone, good afternoon. All right. So, my name is Loïs. I'm the Managing Director of Delhom Acoustics in Dubai. Delhom Acoustics is an international acoustic consultancy company founded in 1995 in France. And over the years, we opened different offices in France, in China, Vietnam, and earlier this year, we opened our agency in Dubai. So the acoustic design projects that we work on are involved in all sectors. Buildings and interiors is one of them, like offices, residential, hospitality, healthcare, etc. But we also do transportation, wind farms as well. We work in environmental acoustics. The performing arts is a very interesting part. And also industrial acoustics and data centers, which is more and more prominent today. So we work with a lot of different types of clients, and in fact we do work with facade engineers very closely because, as some people mentioned in their presentations, acoustics is one of the challenges that we face when designing facades. So why does acoustic matter? Today when we're talking about sound, I think that many people don't really know the impact that it can have on our well-being. This is an example from the WHO that shows that noise is the second largest environmental cause of health problems after air pollution. So we talk a lot about air pollution, but the noise impact is not as heard of. However, the noise impact is really present everywhere in our living environments. Whether it's in schools, in offices, even the patient recovery is impacted by noise. And even in our own homes, it can cause cardiovascular issues, it can cause stress, it can decrease your productivity. So it's quite, and there's many studies you can go online and check. And in fact, when we talk about facade acoustics, it's very much like a turtle's shell. Obviously, there's a visual component to it, and turtles are very beautiful, just like our buildings that we design. But they also have an alternative function, which is to protect ourselves. And in terms of acoustics, it's one of those issues. Before we talk about all of the case study or about what's the process of dealing with acoustics when you're creating your building, one of the first things we need to do is look at the basics. And the first thing is, what is a sound? A sound is actually a pressure wave, and it can travel through lots of different mediums. It can travel through the air, it can travel through concrete, through glass, through your facade. And it's very important to understand that it's not just going up or down. Sound doesn't just go in one direction. It's just like when you throw a stone in the water, you will see the waves going in all the directions. Sound is exactly the same. It's omnidirectional. So many times when we do a building, we see, I've heard this many times, oh, but on the high floors it's much louder. It's not that sound goes up, because actually it goes in many different directions. And this is a little bit of a technical graph talking about frequencies. A sound is made up of many different types of frequencies. You have low frequencies, which is more like traffic noise. You have middle frequencies, like the sound of my voice. We're about between 500 hertz to 2000 hertz. And then you have higher frequencies, and that can be like the birds singing. It can be like the cutlery on the plate in the restaurant. So, And just like in a song, we have bass, we have vocals, and that's really all the frequency spectrum. And when we're doing the acoustic design, we focus mainly between what we can actually hear, which is 20 hertz to 20,000 hertz. That's what we can actually hear when we're talking to each other. That's our ears can hear between that. Elephants can hear much lower, but we're not designing all our buildings for elephants. So we have, for example, different acoustic challenges. Today we're only going to focus on facade insulation, but there's many other issues, and I could go on for hours. So we chose for Zak the facade insulation. So now we're going to talk about how to approach your project in the right way so that we can avoid an over-design. Many times we're not quite sure where to start, what to specify to block the noise. So we don't really have those numbers. But before we can talk about all those specifications, we need to set acoustic targets. It's super important. I'll explain why. When you set your targets, you need to really look at your project in detail. What's the project? Where is it located? Is it in a busy street, like this is in Ho Chi Minh City in Vietnam, which is the 4th loudest city in the world? So it's quite a noisy area. Or are you in the middle of the mountains, in the desert? So this is very important to understand. Because we have traffic noise, for example, which is very prominent in the cities, but it's not always traffic that's the issue. We can have MEP noise, you can see on the rooftop, that can cause from the vibrations, but also from the noise to leak into your building. It could be your own MEP equipment, but it could also be your neighbor's MEP equipment. So it's important to look around. You could have a nightclub, or you could have a concert hall, or, well, in Saudi you could have stadiums being built in different cities. So that's something important to take a look at. And once you know what these noise sources are, you can actually simulate them and see how it's going to impact your facade. So if I wanted to have a look at today, what the noise will impact my facade on today, I can take measurements. I can go on site. I can measure the noise and the frequencies of the vehicles. But we don't build our buildings to live in it for a year and then break it down and build it up again. We're here for the long term. So how do we know? How can we predict the noise and how it will impact your building in the next 10, 15, 20 years? So you can actually have traffic impact studies that will give you the vehicle count per hours or these kind of valuable information. And then through these software, we can actually simulate how that noise will evolve and where are you going to have more impact on your facade. This is an example, for example, on the left here, a facade that is on the same project, but depending on the side, you may see different decibels impacting your facade. So obviously, in this case, we wouldn't tell you to have the same amount of glazing everywhere because some areas are less impacted than others. And this is on a bigger scale. We've done master planning projects and where entire districts are being built, or if, for example, you have an existing district but a new road is going to be built, we can actually see how it's going to impact your environment. It's quite interesting. And so what we were talking about earlier is that depending on the noise levels that we have, for example, I don't know if you can see, over here we have measured, for example, or predicted 70 dB decibels impacting your facade. And so we're going to have an insulation performance, in this case, of 40 decibels. But in zone 2 of the project, the noise level is only at 60 dB. And so, in fact, the performance can go lower. And that's very important because even just a 3 decibel difference can have huge impacts on the cost of your facade because of the specifications can change. And we're going to go back to the frequencies. I don't know if you remember the elephant we talked about. Each type of noise source, of course, has a different volume, but it also has the different frequency. So at the bottom here, we can see that the traffic noise is quite strong in the low frequencies, whereas MEP equipment is quite strong in the middle frequencies. And over here as well for example, a potential nightclub or music. So that's very important to understand because each kind of material will be performing better in different frequencies. So even if you have fantastic glazing, you have triple glazing, but the composition isn't adapted to lower frequencies or higher frequencies, then you can actually have not so much performance that you would have invested in. So it's really important to look at that as well before you invest so that you can save costs. We talked about how externally the environment can impact the targets that you set on your project. But in fact, we also need to look internally. I'll give you an example. We have, for example, a mixed-use project where we have office units or we have residential units. And in fact, in the office, you can allow for more noise intrusion because it's during the day, everyone's talking, so you may not hear as much and you might not be as sensitive to the noise going on outside. So the intrusion you can allow is higher. We can allow around 35 decibels. But if you want to relax, if you're in your room, if you're in a more quiet environment, you might become actually more sensitive to the noise outside, and you may require lesser intrusion on your project. And that's why, for example, 35 decibels can be acceptable in the office space, but 25 for the residential is better. And that will have an impact on the types of glazing and the type of specifications you will have on your facade. So now that we talked about setting your targets, we talked about the project location, we talked about the function of your project as well, we can look at the solutions, but holistically. Here's another, let's say, a technical graph where we have different types of glazing compositions. We have, for example, an 8mm single layer of glass in yellow, and you can see, for example, that in lower frequencies, over here, it actually performs better than a double glazing. This is, we often hear, oh, let's put double glazing because it will perform better, but it depends, again, on the frequencies. So different types of glazing systems will have different values depending on the noise source that you're going to be having on your project. And I spoke about designing holistically, and that's the reason is even if you have very performing glazing, there are still many weak points in your facade that you need to be aware of. One of them is, for example, the mullion. The mullion is a typical weak point, acoustically speaking, that can transmit noise into your building. The frame, of course, can be a weak point if it's not thoughtfully designed. And so you have really different types of weak points that you should be considering and not just focusing on the glazing. And to finish off, we have a quick case study about a successful project that we had in Shanghai, in China. It's an international school. It's a French-German international school. And initially, the client hadn't appointed us on board the project, but they were quite concerned about the noise from the nearby roads. If some of you have been to China, you'll know that they like to build in big quantities. Let's say we have next to the project we have a 12-lane road, which is actually impacting the facade, or so we thought that it would be quite a big impact. And so they asked the local design institute if they could figure out any solution to minimize the intrusion into the classrooms so that it wouldn't disturb the teachers, the students. And so what they proposed initially was a triple glazing on the facade, and which was quite, you can imagine, it's about 50,000 square meter school, so there's quite a lot of facades to cover. It was quite expensive. So the client wasn't sure about the solution and appointed us to have a look by, first of all, taking measurements on site to see if there was actually this big impact. And then we used master planning information to see how the environment around will evolve. And we noticed that, in fact, the project was not being impacted as much as they initially thought. Some facades had more of an exposure to the noise of the road, but others were less exposed. So, in fact, we had a look at the ones that were the most exposed, and we had a specification of around 40 decibels. Whereas the areas that were less exposed, we could bring down by 5 dB, which saved a lot of construction costs. And finally, we also looked at different types of functions inside the room, inside the school. One of them was the canteen, which is a naturally noisy environment, and so you don't really notice that there's cars and trucks passing by because you're busy talking to your friends at lunch. Whereas the classrooms, when you're taking an exam, you do need quite high levels of focus, and if you're being disturbed by traffic noise every 2 minutes, your grades might go down. Proven study. So, in the end, by looking at the function inside the space and looking at how the environment will impact the outside of your facade, we were able to save $1 million of construction costs just by reducing the facade specifications. So that was the successful case study. We have many more, but of course, limited time. So if you want to learn more, feel free to reach out to me, and I'll be happy to talk to you about acoustics. Thank you very much.
Thank you so much. The next speaker will be Mr. Manoj Divakaran. Please welcome on stage. He is the founder and manager director at Mitrex and Empereal Energy. We'll talk about facade. Oh, sorry. This is the old one. Okay. Okay. Please welcome on stage. Okay. Subject. Okay, good. تفضل. Please give him a warm applause.
Thank you.
Thank you.
Good afternoon, everyone. Thank you for being here. I'm quite excited today to introduce Empereal and Mitrex, companies on the forefront of integrating architectural beauty with solar innovation. We are leading companies in building integrated photovoltaics, where we integrate cutting-edge solar solutions to iconic architectural facades. We have been working in the region on many of the iconic solar architectural projects, and in all our work, we try to ensure that we complement or enhance architectural intent and make sure that the design of the building is enhanced at the same time creating a cleaner environment. So, quick introduction. Empereal was founded in 2008. We are headquartered in Singapore, and we operate in projects in India, Middle East, Central Asia, and the US. We touch on all aspects of renewable energy. So we have solar photovoltaic, solar thermal, we do solar water desalination, hydrogen, and architectural solar. And we operate all the way from architectural and solar design at the concept stage through to the actual implementation of projects, and also in some cases on the operating and maintenance of these projects. And we are a strategic alliance partner for Mitrex. Mitrex is one of the leading building integrated photovoltaic companies in the world. They operate the largest manufacturing facility for building integrated photovoltaics in Canada. And their solutions actually allow buildings to be turned into clean power sources. The facades of buildings to become clean power sources without compromising on the aesthetics of the building, and thereby to harness the free energy of the sun to produce a more sustainable future for all of us. So Mitrex has over 25 years experience in various type of facade solutions, starting from stone, ceramics, etc. And for the last 5 years, they have been the leading player in the architectural solar facade space. I'll just quickly, so these facade materials, the building materials that generate energy, the solar facades, they have multiple use cases. They can be used in high-rise buildings, they can be used in residential buildings and balcony railings, etc. They are widely used in data center construction, they're used in educational, parking, industrial facades, etc. So in all of these, they contribute to lowering the carbon footprint, improving the energy generation, and overall creating a far more sustainable and aesthetic facade. So the product itself comprises of a glass front, which can have any color, pattern, or shape, and it's backed up by high efficiency solar cells, and then a backing material, which can be aluminum honeycomb for increased strength, thermal insulation, and various type of backing material based on the design of the facade. We also work in solar glass for balcony railings and separation solutions, and we also work on solar railings as well. So as I mentioned before, the colors span a huge range of colors and patterns. So you can have solar facades which are actually having any of these solid colors, stone finishes. We are working on projects where we are actually mimicking limestone and various other type of stone facades, where from a 1 meter distance you can hardly make out the difference between the solar limestone and the actual limestone itself. Solar wood finishes, brick, metal. They come in all kinds of module shapes and sizes, and it can be curved to meet certain requirements of the design facades. Some of the facades where you need vision, where you need transparency, you have different ways of arranging the solar cells so that you can achieve the required levels of transparency, at the same time have energy generation from the facade itself. We also work on different type of assembly shapes of facades. Facades nowadays have very, very interesting engineering features. So you can have different assembly shapes, very detailed patterns for the returns, and the textures. We can have glass from satin glass all the way up to textured glass, again depending on the architectural requirement. Installation. You can integrate this into standard rain screen solutions using stick facade or factory assembled. We can have unitized facades, and in some markets we are seeing a very big interest in prefabricated facades which are slab to slab. It can be as high as 4 meter high, and you can have a complete solution which has got the thermal insulation, the vapor barrier, all of them coming together with the necessary fixtures inside, so that you have a very quick pace of installation. You can have the factory quality material assembly and a very quick speed of installation. The electricals are very similar to the standard solar installations. You have click-in connectors and you have conduiting, which is actually done along with the original preparation of the facade before the solar panels go on. So this is very straightforward regulatory control mechanisms. When it comes to balconies and other separation solutions, we have different type of solutions where you can have solid colors or you can have transparency solutions, where the electricals of the solutions are brought out in such a way that they are integrated into the railings, so that electrical safety is completely maintained while you're transforming balconies into energy generating solutions. Some examples of projects, you can see on the top right that separation between plots is actually achieved through a white color facade, a solar facade. On the lower side you see a completed project where we can see it's a retrofit project where the balconies were replaced with a solid balcony material, allowing the building to achieve a high level of green certification. For vision areas, you can have different patterns in which you can arrange the solar cells, so that again you can achieve the overall intent of the facade in terms of visual appearance, at the same time achieving the solar generation potential that you need for lowering the electricity cost or for very high green building certifications. Some examples where you actually weave in these transparencies into the facade design itself. Material testing is very important. As I said, this is a building material that generates electricity. So it has to go through a lot of tough testing to make sure that it can withstand the durability requirements of a building facade. Graffiti is a very important thing in many markets. So as I said, being a building material that generates energy, it has to not only undergo all the certification requirements of solar products, it also undergoes a huge amount of certification requirements of the building material. So it comes with the NFPA 285 testing capability. It has got the EN 13501-1 certification with a Class A rating for fire safety. It undergoes various type of wind pressure testing, including the Miami-Dade certification for use in hurricane areas. A lot of UL testing, the ASTM standards. There's a huge amount of testing which keeps going on as more and more standards come out for building integrated products. So quickly touch upon a case study. This was the Scarborough Academy of Medicine and Integrated Health. It's a new building with 143,000 square feet of space. The University of Toronto, which is the ultimate client, owner of the building, they had very strict sustainability targets to meet, and the city also had imposed certain reduction in emissions before the building permits can be obtained for such a building. So in effect, they had to generate 420,000 units of renewable electricity on site in order for the building to proceed from construction point of view as well as to meet its sustainability objectives. In a building like this, the roof space is not enough to generate the kind of on-site energy that is required. Hence, the only way was for the architects to work with the architectural intent and with a facade solution in order to meet the requirements. So we developed 3 different types of solar modules, the Polaris white module and different type of stone lookalike modules. And these modules transformed this facade to be able to generate the energy requirement that it was necessary for the building to meet its design goals. There are challenges. The challenges were about aligning the new building with the university's sustainability goals. We had to offset the energy requirement of the building, and we also had to make sure that the architectural vision is maintained without any changes. And from an outcome perspective, it has transformed this building into an architectural marvel. It is actually talked about in terms of its sustainability footprint and the ability to maintain this architectural look without, while meeting all the sustainability goals. This is a project which is done in Dubai at the Sea Institute, where a brown color, a brown metal finish facade allows this building to achieve one of the highest green building ratings in UAE. I'll touch upon a few more examples. This is another hospital project where the integration of architectural solar allows the building to meet its design and sustainability goals. This is a retrofit project where a very tall facade has been replaced with solar facades not only on the opaque side of it, but also on the stairwell, which also has a high transparency solar. Again, this allows the University of Maryland to actually meet its design and sustainability goals. Another example of a retrofit project where an existing facade is being transformed. This project is under construction. It is being transformed into a completely dynamic facade, including the inclusion of murals, which are actually again constructed using solar modules. This is the retrofit project for balconies that I showed before, which is a completed project where the entire building balcony has been transformed into energy generating balcony sources. Some more projects from the region. This is the UAE pavilion for San Diego Calatrava, which was at the Dubai Expo. So this building is completely covered by white color solar panels. These white color solar panels allow the creation of an aesthetic facade. At the same time, allows this building to become a LEED Platinum rated building. This is a project that is currently ongoing. This is the DEWA headquarters in Dubai. This will be the world's largest net zero building. It's quite a large building, and the entire energy requirements of this building will be achieved from the solar which is on the building. From the roof to the curtain wall facades to various other elements of the building. This is the new headquarters of Masdar. It's covered by a solar canopy, and it's still under construction. You can still see the construction dust on it. It's still under construction. This building, when completed, will be the first large net zero building in our region. The entire energy requirements of the new headquarters of Masdar is actually being generated by solar from this curved canopy. This was a project that we recently completed for Dubai Electricity and Water Authority in Dubai. The portrait of His Highness, the ruler of Dubai, the portrait is actually constructed using solar panels. This might be the world's first fully solar portrait, where the face of the portrait is a 3 kilowatt solar system, 2.5 to 3 kilowatt solar system. And all of these projects are grid connected, which means that the electricity generated by these projects are fed back to the grid and integrated with the grid. In order to do that, you need to meet all the electricity regulatory requirements. So all of these products are designed in such a way that it meets the regulatory requirements for such kind of grid connectivity. This project actually explores the boundaries of what's possible in terms of color, patterns, etc. So here, each of the solar panels have a unique pattern printed onto it, so that when assembled, it can actually create a portrait. Closer to home, this is a project that we've been worked on with the SOM for the Oceanarium project in Jeddah. This is maybe one of the largest building integrated projects in Maldives. More than 25 megawatt of solar integration is taking place onto the various roofs as well as the facades and other areas of the buildings, so that an entire facade can actually become a net zero facade, where no diesel is used. The entire energy requirement for the entire resort is actually generated from solar without losing its architectural intent. It's again a net zero project which is currently under design finalization. You can see here solar has been integrated right from the concept stage to make sure that the architectural intent of curved facades, of a dome, all of these are actually met with the ability to generate solar energy from the facade as well as the roof of the buildings. So why is this important? I think this is important for various architects, contractors, as well as for building owners. For architects, this allows you a full spectrum of architectural freedom. You can have different colors, different shapes, different sizes. It allows you to provide a very high performing building envelope. It allows you up to 40 lead points through the contribution to innovation and various other aspects of the LEED certification. It's building code compliant, it's fire tested, comes with all the building material testing already completed, and helps clients to do the ESG and EPD report. Contractors, likewise, it's a lightweight material, and for building owners, It comes with a 20-year warranty, and that also gives them a very good return on the investment of building facades. Thank you very much.
Okay, thank you. Thank you so much. The next speaker, Yucheng, from SHBO Industry Group. He is International Trade Manager. We'll talk about custom steel, the future of architecture expression. Please give him a warm applause.
Hello, everyone. How to give the slides? How to find here? Just let's click this one. Okay. Hi. So good afternoon, everyone. My name is Richard from SHBO Group. It's a specialty custom steel profiles producer from China. We are very excited to be here in Jeddah with the backdrop to build the tallest building in the world. We believe, sorry.
You have it here, okay. Okay, go ahead.
We believe that our SHBO product will be a perfect match for your ambition to build tall, very tall buildings and tall window walls. I will take this opportunity to explain to you how SHBO can help. With the context of building tall, I would like to table 4 questions. What is the tallest window wall you ever seen? Are you looking into building a super long span window wall? Do you want to build a minimalistic window wall?
There's a clicker here. This is the clicker. Forward and
okay.
This is backward, forward.
Okay. And yes, do you dare to envision a heroic, customized facade? Well, SHBO's custom steel profile can help you achieve this. So first, I would like to show some attributes of custom steel with you. We all know that steel is stronger than aluminum. This attribute makes super tall window walls possible. In Hefei Museum project of China, the number reaches incredible 42 meters. This accommodates endless possibilities for architects' imagination. Second, custom steel can span longer than aluminum, yet with smaller cross-sectional profiles. It is a better option for ultra long-span window wall. Custom steel minimalizes structural elements, increases facade transparency, and lightens building's appearance. In Shanghai World Reception Hall project, we reduced the width of a single profile to astonishing 5 centimeters, improving the visual enjoyment greatly. And custom steel can be customized into diverse curves and trace shapes, allowing for highly flexible, creative architectural design. You can see the irregular shapes designed in Zhangjiang Science Hall project, which will never be achieved by aluminum profile. So I would like to give a summary on custom steel's attributes. What custom steel can bring to architecture? Widen view, long span, slim profiles, minimalistic and irregular shapes. Widening architecture vision. That's how SHBO and our custom steel profile can help in Saudi. Now I would like to give you guys a direct comparison about SHBO custom steel profile and aluminum profile. We can see regarding elastic module, SHBO custom steel profile performance is almost 3 times of that aluminum profile, which means our product is 3 times stronger than common aluminum profile, enabling super tall, long span design. Another point I would like to address is that SHBO custom steel profile's melting point is almost 900 degrees higher than that of aluminum profile, which makes building safer when facing fire accident. Okay, so after the comparison between steel profile and aluminum profile, I'm going to share with you the advantage of SHBO custom steel profile. I mean, there are quite many steel companies in market, but why we are your best choice? Here, I listed a comparison between SHBO standard and the ISO 10721 standard. We can see no matter linearity, verticality, or evenness, length error, SHBO custom steel has better performance than common steel profile. Here, I put a photo comparison between SHBO custom steel and common steel profiles. We can obviously tell that our product has a very small angle, R angle, which makes the profile looks more sharp and solid. The surface is more smooth and flat, as beautiful as aluminum profile. Here, I want to show you some joint connections that we have produced in our previous projects. By the support from our experienced beam team, SHBO has the ability to manufacture different shapes of joint connections, meeting different requirements from architects. Now, allow me to show you the impressive surface possibility of SHBO custom steel profile. First, obviously, we can have multiple color options to meet designers' requirements. What's more, we have unique surface treatment technology, including but not limited to wood surface, which means the appearance looks like a wood, but it's actually steel. And aging copper surface. The appearance looks like copper exposed to outside for a long time, mostly used in urban renewal projects. And brushed surface, making the building very unique. And the last one, my favorite, the surface is as shining as mirror, allows people to see their reflections. Under ISO 12944 coating standard, SHBO has purchased advanced spraying line matched with PPG and axonabare coating. Suitable paint will be selected according to the climate characteristics of the project location to enable our projects to having excellent weather resistance, perfectly cope with the challenges brought by extreme high temperature, humidity, sandstorm, and salt vapor. Due to the high quality of our coating technology, SHBO gave our clients 20-year warranty period. And compared to aluminum profile, SHBO custom steel profile consumes less energy in production process while have a longer service life and lower maintenance cost. The heat transfer coefficient of SHBO custom steel profile is only 1/4 of that of aluminum profile, which means a significant reduction on energy consumption caused by temperature management system inside of buildings. Here I want to talk about some projects we have made before. We focused on China market before. So the first one is called Zhangjiang Science Hall. It's located in Shanghai. The main interest of Zhangjiang Science Hall project is an irregular, twist and curved shell structure. Due to the complex of the structure, the architect wanted a more cast-iron and lightweight expression. So SHBO custom steel profile was chosen as the material for supporting the keel. To reduce the difficulty of installation on site, our SHBO team used beam modeling for guidance. The overall structure was divided into 40 transportable units and assembled in factory. Finally, each unit was scanned in 3D to ensure the occurrence of on-site installation, while reducing on-site welding and shortening the construction period. And I'm going to show you some other projects we have made before. Okay, thank you.
Okay, now for the last event for today, the panel discussion. So I would like to call on stage our moderator and speakers, Mr. Ahmed Qasibi, Walaa Addas, Jamil Adra. The discussion topic is the evolution of local architecture identity. Please give them a warm applause.
Yes, assalamu alaikum. So our panel discussion speaking about the evaluation of local architectural identity. As you know, Salmani architecture still blends the tradition with contemporary design elements in both historical aspects and the modern complexity of architecture. So in starting with engineer Jamil,
ladies first.
It's okay. What are the key challenges in maintaining the essence of traditional Najdi while incorporating contemporary design elements? How do you approach these challenges in your projects?
Okay. Thank you for inviting me to be a panelist in this event, and thank you for audience to bear with us up to the end of the event. Actually, the Salmani architecture is giving the chance to the Riyadh city to have an identity. Whenever you are moving or driving in Riyadh, you can see a lot of different type of architecture depending on the years of experience, years of construction. So you can see buildings with the 70s, concrete blocks, curved balconies, and then whenever you move forward, you can see the skyscrapers with the crazy glass elevations. And then nowadays, we can see that we are having kind of identity that will give the impression that you are in the capital of the Kingdom of Saudi Arabia. How we are going to merge or marry the traditional architecture with the contemporary design is the Salmani architecture is giving us kind of design guidance. It's giving some rules and regulations that will allow us to follow the DNA of the city. And every challenge, should be an opportunity for the designer. Whenever you have challenge, so this is your opportunity to innovate and to be more creative, to present something that is going to reflect this new identity or it's not a new identity, but it's just to reveal the identity of the city.
Engineer Walaa, how do you see the principles of Salmani architecture has influenced the overall architectural identity of Riyadh?
Well, the design principles have definitely, as my colleague said, been part of maintaining design guidelines in general for the identity to start appearing, but also as the charter of the Salmani architecture also press on authenticity, continuity, centrality, and sustainability for sure. So coming all together in building this image, it will also help the future architects to be inspired from this identity itself to keep up with the city expansion towards even the whole region of Riyadh.
So speaking more about not only the Najdi style, we can speak also about Hijazi, as you are from Jeddah development, so and Assyri style, yeah.
Exactly. So each region should have its own. This is what we encourage actually as urban and city planners. Region can start looking into their own environment, public fabric, cultural context, and build on their own identity. But as you know, it's part of design principle unity within variety. So we're all going to be, after all, unified because we share the same climate, we same culture, religion, language, etc. But it's just the differentiate between a contextual, cultural backgrounds. From Jeddah. Jeddah, most probably, as we said today, is the most historic city with a variety in culture. So this can be a bit more of a complex to determine which direction towards. Asir is very much different in geographic patterns, and Riyadh has very much succeeded in bringing the charter in Riyadh city, and hopefully the rest of the kingdom can follow.
If you allow me here, you know, the architecture should reflect the identity of the place. You should have the sense of the place. So if I'm in the, if I'm on the sea level, I cannot see rocky mountains just on the sea level if you are here in Jeddah. It's not there. It's going to be really looks like really odd. Nobody will accept it. And the same whenever you are in the downtown, just planting some trees doesn't make this place as oasis. So it should be part of the place. You need to feel the sense of the place. And this is why the architecture is too much related to to the earth, to the place, to the resources, the natural resources that you have. And as elements, you have always the same elements. You have the Roshan, and you have the Mashrabiya, and you have the Talma. However, every place is reflecting it and designing it based on their local culture and the local materials.
I may add, because Jeddah is a very, as I said, geographically also it has a variety, not just from a cultural background that we had versified cultures coming along. If you look in Jeddah today, we have boomed not just along the seashore, but also towards the eastern of Jeddah. And therefore we can actually glimpse the skyline of the mountains. So here when we start to think about our guidelines, it also, again, we're back to versified and variety. So people might be living in the east of Jeddah, might follow different architectural guidelines that is more resembling with the earthy tones nature, which is the mountains, والهضاب اللي بنشوفها. Where people living across the coastal side, they have a resemblance of more unique, inspired morely from the Balad, where it was located nearby the Buhayrat al-Shabab, al-Arba'in, and so on. So again, Jeddah is quite complex. It is very much not just complex. It is it has varies actually, even with people or with the environmental situations. Where I think in Riyadh, it's more or less it's a round city, differently from a longitudinal city that has actually a seaside and a mountain look and feel.
Don't forget Jabal Tuwek again. As you know, facade design challenges including architectural integrity, balancing local material selections, building envelope performance, thermal and acoustic, the right transitioning to net zero projects, and also the meeting the LEED compliance and local regulations, and for sure architectural functionality. So what are the key considerations when selecting materials for facade design, especially when ensuring both building envelope performance and aesthetic appeal?
Sorry. You know, whenever we are designing any building, we should put in our mind that we need to be sustainable, regardless if we are going to have the LEED certification or not. Sustainability should be part of our daily practice. So selecting material, it should help. You know, it's now very weird to see people talking about the lifetime of the building. It should live forever. This is how we knew the previous culture and the previous civilizations. And what we are building today, this is going to be for the future generations. It's not only for us and our children, it's going to be for our grandchildren. It should last forever. So this is why we need to look for the sustainability regardless of any type of certification. Going sustainable, this will help us as well to be more economically feasible for the lifetime of the building. Whenever we are providing proper material, preserving the environment, so we are minimizing the carbon footprint. Whenever we are providing proper acoustic insulation for the building, so we are using less energy to provide HVAC, and this will help as well in maintaining the natural resources of the city. So this is how we need to think whenever we are designing. If the aluminum cladding is going to help me in this, I will be more than happy to use the aluminum cladding if it is as well part of the natural resources. However, it's not. So why do I need to go for it and put it? Don't hate me the aluminum cladding providers, please don't hate me for that, but it's not in the culture, it's not here. So first of all, we are importing it. Second of all, it's not part of the natural resources here in the city, not in the city, the whole kingdom actually. And you know, it's just copying something, innovating just to follow the trend. We should not be like that. We really need to be sustainable by selecting the material that's going to help the global system of the place.
Yes, exactly. That's why we can see the high standards of sustainability that we are working on, the material to be EBD, HBD certified, green ecosystem, since manufacturing the material to cradle to grave, LCA life cycle assessment for each material. From your standpoint, Walaa, how do you see the principles of using the local material, especially now focusing in Riyadh culture, okay, the Najd side, the mud render, the right transitioning to new generations of materials. So we are speaking about the regulations that supports the designers, like RCRC standards. When speaking about the facade, they help the designers to show the identity of Riyadh. Especially, they are speaking about the glass percentage, the window wall ratio, the wall to floor ratio. That really guiding the architects to select the right material, and also with keeping performance and structural in mind. So from your standpoint, when you're developing Jeddah, middle of Jeddah at the moment, and we have rich culture with Hijazi, how do you see this transition can be reflected in your projects?
Well, that's a great question, because today my presentation, it was about cultural facadism, and the only answer to this question for me is materiality selection, smart selection. By means, we have to dig into our own environmental context. Look what exactly available. I know Hajar al-Mangabi, which is coral stone, is no longer affordable as it used to, but what we can do is we try our best to select local materials, not just for cost issue, but it's even energy efficient for, you know, to think about how would you mobilize these materials, the sources. Also, when you look back in history, Roshans made were transported. Actually, as I said today, we don't have forests to get all these wood from, but with innovation and technology today, I know we're not manufacturing all type of materials, but what we can have locally, smart selection towards energy innovation, modern interpretation of these facades. So the answer to keep up with all the cultural context and reflect the heritage through adaptive reuse is the smart selection of material. Along taste, taste actually plays a huge role in selecting these materials, because it's not just giving you a striking, meticulous exterior look, but also it tells a story, the soul of this building, users. So we need to tell these stories, not just for our children, but we have to hit for 100 years of sustainable approach.
All right. So Engineer Jamil, from your standpoint, how do you see the right transitioning when selecting the material at the moment?
You know, let's talk, for example, I'll give an example in Riyadh at the moment. For example, the traditional architecture in Riyadh was muddy. They were using the mud. So now, are you going to use the mud as well? It's not possible. Of course, it's not possible. So this is why now we are moving to the natural stone, the Riyadh stone. And there is different type of Riyadh stone, different category. So, and then at the end of the day, you cannot keep doing the same issue, have everything with the Riyadh stone. So now our colleagues, they are providing the new materials with the terracotta and other type of cladding that's going to give and reflect the same nature that you have. And then you can innovate new tiles, actually, and this is what now the Royal Commission of Riyadh City, they are now approving some tiles that they are really matching with the Riyadh stone that can be used in the elevations of the new buildings at the moment. This is really helping a lot of, especially whenever you are going to apply the Salmani architecture. You know, the Najdi architecture, it's not high-rise, it's like 2-story, 3 stories maximum, because this is what these were the tools and resources that they have. Now we are talking about 30 meters high building, even 30 floors high building. So how we are going to apply these elements on the top of this this building? We can see that it's already applied. If you go to the Qasr al-Hukm area and you see Masjid al-Kabir, the minaret, it's fully cladded. This is great because we have
Salman roads, yeah.
Exactly. Waras and Badran did very great job actually in that project, and thanks God there is a now field called the facade engineering. They are helping us to achieve these goals. So yes, we can evaluate more in the material, and then nothing should be impossible for us. Our ancestors, they had very poor tools, and they did great job that we can see up to now, since 100 years and thousands of years. So why not now, with all this technology, we cannot achieve these goals?
Yeah, and this is the importance as a designers during the concept design, when we are doing multi-proposals for each side of the building, investigated in early stage, the materiality, modularity, the tolerances, the manufacturing limitations, and with keeping in mind the energy-wise carbon engineering.
You know, this is why the specialist consultant should be on board from day one. So he's going to give guidance to the architect. The architect, yeah, he will like to go out of the box and design something that's going to be landmark forever. However, this piece of art to be really constructed, it needs a specialist designer, specialist engineer who's going to guide him about all these engineering and scientific rules and regulations to be able to make it achievable.
Would you like to add something to the concept?
The concept for Riyadh?
Yeah. What we can see
well,
now
we
in
want
the
to see the same happening in Jeddah, because as I was just saying, that we have an issue in the same local materiality, which is instead of mud, we have it coral stone. So I'm trying to reflect with your answer. So we need also to look into similar sources and to try to bring up the same look and feel of the architectural essence that is morely of a stone, representing a coastal city.
So speaking about the structural integrity with the how to use the structure, from constructability point of view, we can use the construction to increase the building performance. For instance, you are increasing the shading areas on the facades using vertical blades, inclined blades. From geometrical standpoints, using striped concrete to increase the shadow. How do you see, as a designer, from geometrical standpoints, how we can support the building sustainability by creating a creative structure that more sustainable to the design itself?
You know, shade and shadow are the most important elements whenever you are designing. So this will emphasize the element that you would like to see. And thanks to the construction methodologies that are available these days, talking about the steel structure and the concrete structure, this will allow us to have the intention to give more challenging designs, actually, and challenging our structural designers to have these protrusions and punches inside the volume of the building that will allow us really to emphasize on some elements, and providing the shade is as important as providing a shadow. So the orientation of the building plus these protrusions and punches, this will give us the flexibility.
I was inspired by Majid's presentation previously, that he's speaking about the operable windows that under the positive and negative wind load. Yeah. So this is the importance of doing the CFD analysis to understand the simulation, how the airflow that coming inside the property, and what is the right allocating of the building inside the property border, and the right orientation of the openings and determination. The openings type, so fixed, operable, and the size of openings.
All the traditional buildings, they have, you cannot see any window which is not located in the right place, because they were putting the window where they need. It's not just for the beauty and aesthetic of the building. It's always has a function and it works very properly. And then, if they have the luxury to make it ornamental, they will do it. For example, previously, whenever you are looking to the doors, all the doors looks kind of an evaluation of a single design. If whenever he start the building, he has little money and then he's done, and then he get more money. So he start ornamenting more the door to show, because the elevation is reflection of the identity of the person. So who's using this building. So he start adding more ornaments to show them that yes, I have good money and I can do more. And then these ornamental doors are dedicated for the guest, not for the family members. The family members, they have smaller door to access it because they are more humble and to go there, not big doors to open it for the guest. So each elements in the architecture has a function. If we really go into that, our buildings are going to be much nicer.
This is the main challenge, how to use the structure without complex the architecture functionality. Yeah.
Exactly. It's not just providing cantilever of 20 meters that would make the building nicer. If it is needed, yes.
Well, as you know, when designing the building, we have to understand what is the principle, what is the purpose of the building. Okay, it's a high-rise residential blocks, steel, concrete, or a combination, and understanding how this building can be performed and how that guide us to the right thermal assessment of the building. So in Jeddah, we are using a lot of architectural elements, which is really great, like Roshan, Mishrabiyas, these horizontal shaded elements with the wood, the right integration with the other facade materials. So from your standpoint, how do you see the importance of testing the performance of the materials, and also how to use it in the right efficient way in the building before reaching doing the biggest step to test the 3D renders and to see how all elements looks together?
Well, definitely we go through a phase of material selection. So material selection for us, we should understand each nature, whether it's a heat lock or heat gain into the indoor of the building. But here my friend says something also interesting, which is culturally, when we studied the old housing, we know they lived with no AC, okay? So once you are inside these old houses, it's really nice that there is a wind catch, which is, they know where to place their windows. We call it in Arabic صفق الهواء, means where you get the breeze
prevailing wind.
hitting you.
Yes. The right ventilation.
Exactly, it's a right ventilation and it's very smart. And also when we go to Al-Balad and we walk through, sometimes even, let's talk about it from a architectural towards a public realm sort of situation. The orientation of the building actually is placed where to block the direct sun exposure to the pedestrianized area while giving you this great wind breeze. And definitely in summer, it's very hot that time, so they used to live in the upper level of the building. So they know what they were doing. It was very smart. So we translate that today with our technology. Definitely we have AC, but insulation, as my colleagues before, they are more technical in materials. They know which material usually could lock the heat outside, yet let maybe the sun light comes within the building, such also the new technology of glass, where we do not need to use more Roshan, for example, but these glazing units have insulation, so they can reject the sun exposure while allowing only light, so it keeps the indoor just lightened through the day while it's not very much hot, so you can save more on the energy consumption of the house.
Reducing heat and controlling
Reducing
the glare,
heat, yeah, exactly.
Especially, yeah. So the last question, actually, Engineer Jamal, in your experience, how is the approach of structural integration and facade design over the years in Saudi Arabia? Since you are working in this market since 30 years, how do you see the evaluation had been really developed till today?
Yeah, you can see it in the street, actually. Whenever you are walking in the street, you can see how the architecture really evaluate in Saudi Arabia. There was some booms in wrong places, yeah, but we are passing this. Before, you cannot see these skyscrapers. You cannot see all this technology in the building. There was always problem about how we are going to maintain the building and doing the proper maintenance for the building. Because having these buildings without any proper maintenance, regardless what material you are going to do, if you are not going to maintain it, it's not going to serve you. So it's not only building it, but maintaining it as well. And nowadays, this is happening. Previously, you can walk through a building which is 5 years old, but you feel that you need to demolish it and take it out because it's already old. There is now new regulations in the kingdom about how we build for the construction. The Saudi code is really putting the right regulations.
I believe Saudi code reached to LEED silver category.
100%. And it was a bit late, but it learned from all other previous experiences. The Saudi code used the lesson learned from other codes and then combined it together in one code, which is really very good. It's really pushing all the new construction to be sustainable, regardless if it is small building, small villa, or skyscraper. Everybody should be going into the sustainability, using the proper material, and being safe. We don't need to forget the fire and life safety. Especially, we heard a lot previously about fire incident happening in schools and markets, and they cannot be saved. Nowadays, it's much more controlled and much more safer for the end users.
Walaa, since you are a Saudi citizen and you belong to Jeddah, how do you see the overall architecture had been developed in Jeddah?
Okay. So in the past 5 years, actually, there's a great change, because not just me personally was working as a consultant in shaping the city overall architectural guidelines, but definitely we have been working in the past 5 years and shaping the identity of Jeddah city, as we were discussing today, in terms of land use, facades, public realm, surrounding. Definitely the most critical part is infrastructure and mobility. So once this is solved, usually it does link with the buildings and architecture. So far, like new developments are popping, so it's like a stitching from the old town towards the downtown city centers, toward the new northern side of Jeddah. And it's really very much expanding. It does need to go under rules and regulation, coding system for sure, to not just construct the image and give a striking aesthetic view, but also to press on the deep cultural roots of the city.
Yeah, this is the main target actually for all designers, to show the architectural identity of Saudi, to reach to a compiling to solutions that compiling intersections between the aesthetic appeal, sustainability, environmental, and technological innovation, actually, to the right use of the technologies. I believe that this is the end of this panel. I would like to hear if any questions from audience. No questions? Okay, thank you so much for your time.
Thank you.
Walaa. Thank you.
Thank you. Thank you so much.
Guys, this is the end of the conference. Thank you very much to all our speakers. Thank you to everyone who stayed till the end. We will be uploading this on YouTube, the whole conference. We'll have photos available, so stay tuned, and I guess see you next year. Thank you so much.